Hi guys, welcome to Mastering Ethical Hacking Skills using Python course. My name is Muhammad Askar and I will be the main instructor for this course. This is the first lecture from this course and it will be about the course sections. We will talk about the main sections at this course. As you can see, this course is divided into 6 main sections. The first section will be about warming up. At this section, we will talk about how we can build our labs and set up our environment. And this environment, we will use it during this course. I will not teach you Python programming language basics. I will teach you much more than that. I will teach you how to use Python programming language during any penetration testing or ethical hacking operation. Network security with Python. At this section, we will talk about how we can build tools like customized port scanner, like Wi-Fi jammer, and how to bypass firewall and IDS, IPS, or any other protection on the network, and so on. Web application security with Python. At this section, we will talk about how we can write an exploit to exploit a web application vulnerabilities, and how to build the crawlers, and how to retrieve data from the web application by exploiting, as I said, a web application vulnerabilities. Endpoint security with Python. At this section, we will talk about how we can use Python to create backdoors, trojans, worms, to make sure that our endpoints are totally secured. And we will talk about the eternal blue vulnerability, and we will analyze it and learn how to use it on our backdoors, for an example. Buffer overflow basics with Python. At this section, we will talk about how we can exploit a buffer overflow vulnerabilities on Windows platform, how to write a file fuzzer, for an example, how to write a TCP fuzzer, and so on. Encryption basics with Python. At this section, we will talk about how to use DACE algorithms to encrypt and decrypt files, and how we can create a totally secured communication channels with Python, of course. So this is all about this course section, of course, and this is all about this lecture. See you in the next lecture. Hi guys, welcome to Mastering Ethical Hacking Skills using Python course. Today we will talk about the labs setup. The labs is an isolated network. We will test it and test our tools on it and perform an attacks on it to try to hack it, of course. We need Python 2.7 at least. We need VMware Workstation or VirtualBox or any other virtualization software. I will use VMware Workstation with 3 Windows 7 machines. You can use 2 Windows 7 machines, but I will use the 3 Windows 7 machines. We need 1 Linux machine. I will use Ubuntu as my main machine. And of course, feel free to pick up your favorite IDE or code editor. I will use Atom and Nano. Okay, let's get started. This is the main machine that I got. You can see here I have 3 machines. Windows 7 for Attacker's machine, Bob's machine, and Harry's machine. In this course, we will try to hack Bob's and Harry's machine using the attacker's machine. Of course, we will use the Ubuntu and Linux operating system, which is connected to this network, to try to hack Bob's machine and Harry's machine also. Make sure that every device and every virtual machine are connected in NAT mode. In the network adapter, network connection, make sure that it's connected with a NAT, okay? So we can make an isolated network and perform the tests and the attacks on it. Okay, let's go to python.org on our network, on our attacker's machine. Go to python.org. Downloads, we need to download Python 2.7.13. Click on it, save it, and install it. Okay. Before we get started, I have to tell you guys that we will not install anything right now. Expect also Python, of course, but In other sections, and later on, we will discuss how to install pip, PyInstaller, Py2xe, and all the software that we need. That's all we need for the attacker's machine for now. Let's go to Linux operating system, to the terminal. We will see the opt course examples. This is the main directory. We will save the code examples, the tools that we will build on it. I will use Python 2.7. As we can see, I have Python 2.7.12. We will use this machine to build the tools, to start building the tools. In the fourth section, which is the endpoint security section, we will use the virtual machines to build the tools, to build the malwares, the Trojans. So that's all for today. I hope you guys enjoyed that. See you in the next lecture. Hi guys and welcome. In this video, we will talk about how we can use Netcat for communication and how we can use Netcat to transmit data between two devices. Netcat is a very useful and helpful tool for all penetration testers. You have to know how to use Netcat if you want to perform a successfully data transmission between two devices in a very quick way. So, in this course, we will use Netcat for many purposes. And I want to make a quick revision and a quick explanation, of course, for Netcat. So we will start using Netcat on Ubuntu, and of course we can use Netcat on Windows. You can download it from this website. After downloading it, I extracted it and I just get this executable file, which is the Netcat file. I will use this file, netcat.exe, of course, to communicate between two devices and to transmit the data between them. So I will use Netcat on Windows, on Ubuntu, my Ubuntu device, on Linux device, using ANSI-VLP. V mean purpose, L mean listen, P to the port. So I will listen to port 1337 and I'll press enter. As we can see, I can listen on the port and I'm listening on the port now without any problem. I will now use another Netcat version on Windows and try to connect to the host and the port. But first I will use help. As we can see, this help banner help us to know more about the options that we can use in Netcat. Of course, I use the netcat-lp to use the host, the port that we want to listen on, and to start a TCP or listening on it without any problem. So before that, I will just make sure that I run Wireshark to listen on the interface and to explain more about what is happening actually when I try to connect to other device. I will just, I will make the listen here and I will listen to the port 1337. Now we are listening on this IP, which is 172.16.120.136. We will try to communicate and to connect to this host and try what is actually working there. So I will use, okay, no problem. I will use here the Wireshark, I will use Netcat here, netcat-vv to connect with purpose, to show the purpose. Then we will enter the host that we want to connect to. Then we will enter the port number, which is 1337. And I now will press enter, but I'll make sure that this are good to you. When I press enter, I can see here in Wireshark that I did a very quick three-way handshake. As we can see, I send the SYN, then I received SYNAC, and I get the acknowledgement. I send the acknowledgement, which means that this port is open. This is the three-way handshake. You can read more about TCP protocol to know more about it, but mainly this is the TCP three-way handshake in TCP actually. Yeah. So we send SYN flag, we received SYNAC, and we send ACK again, which means this port is open. And as we can see here, we received a connection from our device, which is 172.16.1201. So we can now send and transmit the data without any problem. We can send hi, for example. We send the hi here. We can see that we received hi here without any problem. We can reply hi, how are you? We can see that we get how are you here. So we transmit data between two devices using Netcat, and we can use it. Actually, we can see here that we the data that we send and the data we are transmit without any problem with this host actually here. You can see that if we go to follow TCP stream, you can see that yep, we can read what is happening using Wireshark. So we will use Netcat in many different ways in next lectures, and we will learn how we can use Netcat to control our shells, our Python shells. So there is another trick on Netcat. We can use Netcat to start, let's say, a reverse shell just with a Netcat. We can use that. Simply, I will netcat-vlp. I will listen to port 1337 again. Then I will use the option -e to let's say invoke and use the program cmd.exe and pass all the arguments to cmd.exe, and I will press enter. Now, any connection that I will receive from any other host, it will be like a reverse shell, and I will just connect to it without any problem. Now, we will just actually netcat here, vv. We'll try to connect to this host and to this port. This is we have a bind shell here, not a reverse shell, but it's just to show you the techniques. The main techniques that we will use, it's actually two techniques. The first technique is using this way, which I bind into a port and listen into a port actually. Then I'm trying to connect to it, and if we can see, I send who am I? Sorry, got a problem? Yep, if we got a how am I here, it's just delayed. If I get a dir, I get a very simple shell, CMD shell, command shell without any problem. So actually I can did it in Linux too. If I just CLS, sorry. If I use netcat-vlp 1337, of course, actually I will use the -e command without any problem. Then pen-sh. It's the equivalent of the CMD button in Linux. So I press enter now. Oops, sorry. I'm sorry. I will use the new version, the updated version of Netcat on Linux. I will use ncat to show you a couple of things. Netcat. Then I will use -e pen-sh. Then I will listen on port 1337 and I will press enter. ncat is another version of updated version of Netcat. You can use it on Linux to use SSL, to use more commands and options in Linux. I just mistyped the first version, which is ANSI. Now ANSI and ncat is different, so you have to know that. I'm going to try to execute or to connect to the host. I'm sorry, here. netcat.exe -vv172.16.1.1337, and I'll press enter. We can see that we got a connection here. We don't have a problem. Yep, a connection coming. Now we can execute the comments, if I try to execute ID, I can see I get a root, who am I, uname-a, uname, and we don't have any problem executing these comments. So I want to show you the ncat, the new Netcat, the new version and the updated version of Netcat, because we can use Netcat over SSL, and we will talk about that in the next lecture. And in the previous lecture, we talked about how you can set up the labs, and the labs is very important to you if you want to test Netcat between two or more devices. So in the next lecture, we will talk about the Python sockets. I hope you guys enjoy the Python sockets and the other lectures about network security. In the endpoint security section, we will talk more about ncat, and of course in the encryption section, when we talk about the SSL over Netcat, we will talk more about it later on. So hope you guys enjoy this video, and see you in the next lecture. Hi guys, welcome to Mastering Ethical Hacking Skills using Python course. Today we're going to talk about Python sockets. We will talk about how we can build Python sockets, how we can communicate with other devices using sockets, how to send and receive data using sockets. And we will talk about how we can build that using Python programming language, of course. In this lecture, we will answer some questions like what is Python sockets, where we can use Python sockets, and how we can use it as security guys. Okay, let's get started. We have first to read the Python documentation for socket. You can find a lot of very useful information about socket in Python. I will give you and I will show you the basics of sockets in this course and how we can deal with socket in general. If you want to get deep and deeper, you can use this documentation as your first guide. So we need to make sure that everything is clear to us. In the socket, we need to determine what is the address that we want to connect to. The address, which means the host and the port that we want to connect to. In socket.af inet, we mean that we want to connect to IP version 4 address. Socket.af underscore inet 6, that means we want to connect with IP version 6 protocol. IP version 6 address. The socket.sockstream means that we want to use TCP as a network protocol to communicate with the device. The first assignment for you guys is to write a paragraph about the sockets family, socket, sockrow, sockrdm, socksec packet. The sockstream, as I said, it's used for TCP connection, generally used for TCP connection. Socket.sock underscore dgram used to use UDP protocol to communicate with the devices. I want from you guys to write more about the sockrow, sockrdm, socksec packet, and so on about them and how you can use them and what is the main usage for them. Okay, now let's get started the code and write a simple script that helps us to communicate with other devices using IP version 4 and how we can use that using Python. First of all, let's determine the path of the interpreter, user pin Python 2.7, and let's import the socket library using import, then socket. So we will import the socket library and press enter to create an object now from socket library, which is sock for an example. Sorry, sock equals socket.socket. Now in this line we initialize a socket, but we have to be more specific. Let's determine the socket family that we want to use. We will give socket.af underscore net socket.sockstream, sock.sockstream. Okay, we determine that we want to deal with IP version 4 and we need to communicate using TCP connection or TCP protocol, I'm sorry. Okay, now We want to connect to the host. If we want to connect to the host using sockets, we need to type sock.socket as connectory, and the method inside this method. It takes one argument as a tuple, like this, a parameter. It would be like a tuple. Okay, this tuple takes two elements. The first element would be string as host, and the second one would be integer as port. So the first element, which is the address, will be string, for example, localhost. The second element will be the port, which is, for example, 4040. Okay, now we initialize the socket and we determine the family of the socket, and now we connect to the host that we want to connect to. We determine the local host and the port, as I mentioned before. Now we want to send the data that we want to send to this host. We need to type sock.send. Send method will let us send data to this host after we accomplish a connection with it. We need we need the host to be a real host, an existed host, for example, not a non-existed host, or we can't connect to this host, and we need an open port to communicate with. So I determined localhost and 4040 as an port. Now let us send the data. The data will be high with a line terminator. Okay, now with these four codes, actually, 4 line of codes, we write a simple script that transmit the data between us and other device. But let us modify the script to be more professional. We need to do this. Let's make some exception handling, try and accept to make sure that everything is good. With a tab, accept. With a tab, accept socket error, of course. The socket error, sorry, if we gone into socket error here, the exception, that this exception is raised for socket related errors. That means maybe the host is non-exist, or the port is closed, or there's firewall to deny us from connect to this host. So anyway, if the connection went good, we'll print, for example, connection done, and print if any error happened. We will print, for example, error, and this sad face. Okay, let's save this data, save it, and go to our terminal. We will use Netcat to listen to the port, netcat-plp, verpus listen to port. I assume that you used Netcat before. If not, let me give you a brief about Netcat. Netcat is a tool that helps us to communicate with other devices or to listen to local ports. So here we need to, or we tell Netcat to listen to port, to specified port, listen LP to the port, and verpus to print out the results and all operations that happens in Netcat for this moment. So we need to 4040. Okay, as we can see, we're listening now on localhost and port 4040. We need to execute the script, and the script should send hi as an argument, as a data to this Netcat connection. So we need to Python 2.7 example1.py and that presenter, and bingo. As we can see, connection done in our client, and in the server we see that the connection to port 4040 accepted, and we send hi with a line terminator to this socket. Okay, that's very good. We need to do some modification for this course, for the script, I'm sorry. Let's import sys library to take input from the user. We will initialize a variable host equals sys.argv1 as an argument value 1 as the first input from the user, and port we will take it as integer from sys.argv2 as the second argument from the from the user. We'll change the host, and here we will change the port, so we can let the user determine the host and the port that he wants to connect to. Okay, we will do like this, netcat VLP. Let's say this time we need 5050. Okay, so just let me do this. Okay, and now we will enter the first argument, the host that we want to connect to, 127.0, which is the local host. And we will, let's just be more clear for you. Now this address is equal localhost, okay, but I will type localhost, no problem with that. Localhost 5050 to be more clear for you guys. Okay, now it should, when press enter, it should, as we can see, print hi and connection done for us. Okay, that's perfect. That's very, very, very great. Okay. Okay, guys. Now we write the script to deal with the socket in a very simple way, and very basic way. That is enough for today. And this lecture, we learned how to initialize the socket, as I mentioned, how to connect to a device, and how to send the data. In the next lecture, we will talk about how we can use socket to write a port scanner, a fully customized port scanner. So, see you in the next lecture. Hi guys, welcome to Mastering Ethical Hacking using Python course. Today, we will talk about how we can write customized port scanner in Python. Of course, this scanner will be written in using Python sockets in Python programming language, as I mentioned. Also, this scanner will be fully customized, which means that we can add any feature that we want to this scanner. And in this lecture, we will learn how to perform a penalty grabbing and how to get the version of the service that is currently working on the machine. During this lecture, we will try to scan the machine of Bob's machine here, as you can see. We will scan Bob's machine and extract all the open ports from it. Okay, let's get started. Before we get started, we will review the script that we wrote in the previous lecture. As we can see here, we import socket and sys library, socket library to make the connection, and sys to take two arguments, host and port. Then we initialize a socket with IP version for support and with using TCP protocol. Then we try to connect to the host. If any exception happened, we'll print error for me. If all things going good actually, the script will print connection done. We just send hi as data to the system, and this is all about the sockets that we talked about in the previous lecture. Today, we'll use the same logic to test the script that we will write in this lecture to perform a port scanner on any host that we want. So let's get started with the interpreter path. We to point to Python 2.7. Then we will import socket and sys. Sys to take the argument again, and socket to handling the connection as we talked before. We will initialize a variable with the host, or let's say target, equal sys.argv1. Then we will do the following. We will generate the ports that we were going to scan. Let's say that we wanted to scan first 2000 port. We will need the range function. It's not make a sense to write them in array, or in list, sorry. List L1 equal port 1, 2, 3, 4, 5, 6, 7. No, it's not make sense to do that. We need something automated to generate the ports for us. So we need to use range function. The range function, you can give it a range to generate an array with a number of elements, a number of integers too. So let us use the Python interpreter here, just Udemy profile, Python 2.7, range, we can see 2001 to generate these elements, actually starting from 0, of course. because that I add 1 to 2000, so we have 2000 elements. If we want 2001 elements, actually starting from 0, if we need to generate 1 to 2000 element, we give the start address and the our offset, start offset and the end offset. We will press enter. We'll see that range function generated a list for me which contains 2000 element. Okay, that's great. Now we will say the ports here. We will initialize another variable with ports equal range from 1 to 2001. To generate that, again, 2000 integer, start from 1 to 2000. So in this case, I got my 2000 ports imports variable, which is a list variable, of course. Okay, now we will start to make a try. Try, we will do suck equal socket dot socket, and we will choose the family socket dot af underscore inet. We will socket dot sock stream, of course, to determine that we need IB version, or we'll deal with IB version 4, and we dealing with TCP or using TCP connection. We will make sure that we are connecting to the host and the port, which we learn to use the connect method. But in this lesson, we will use connect underscore ex to connect with the host and the port. Okay, but we need to initialize something here, guys. We need to put this try in a for loop so we can extract each element from this list, which is contain the 2000 element that we generated. So we need to do the following: for I in range, or let's say for port would be better, for port and ports, we will do the following: try with an indent, of course, suck, and port. We will check if the status of the connection was equal 0, which means that everything was good, there is no problem with me. We will connect, or we will print this message. Let it be print. Print. Okay, print. Maybe the port with some of format string here. Format port. Okay, is open. Okay, sorry, open. So if the port is open, we will try to connect and initialize the socket. If the connection goes good and there is no problem with this, we will raise the port is open. Else, we'll print. I'm sorry, there's print here. Okay, print the port and 0 is closed. Okay, closed, and here opened. Okay, dot format, of course, the port. Let's say that here we have an exception, or we had an exception, except socket error. We talked about socket error in the previous lecture. Let's say except print here like this, error with socket, for example. Okay, we will test the script. Let's say that example 2. We will go to let's go exit from the interpreter, opt course example Python 2.7, and we will say example 2.py, and we will give the localhost for just testing purposes, and we will press enter. I'm sorry, here's suck dot. Okay, I forgot to add the suck. Okay, let's say enter. Oops, it is about, target. I used to type it as target. Okay, let's press enter and see what will happen actually. As we can see, we get the result from scanning our local machine. We said that we can see that we got the 22 port is opened. We can see that we got 80 is opened, and we can see all the open and closed ports in a range 2000 port. If we need to port more or scan more ports, we can just generate more ports from range function. Otherwise, you can just go with this 2000 ports. Now, if we want to just print the opened port, we need to comment out this lines and try again Python example2.py in the localhost, and we will see that, yeah, we got the open ports, all open ports in the range 2000 port, and we definitely programmed this script or the tool, whatever you want to call it, successfully, and we get the job done. Now, we want to scan POP's machine here. Let's get POP's machine, IP config. Okay, we will scan this IP address for testing purposes. We'll take this IP in this way. We will say I want to scan Python, I want to scan this host, and I will press enter. As we can see, we can see the ports, the open ports. We can see all the open ports within the range 2000 port without any problem, and in a clear way. We can see that we are we discovered the open port within the 2000 ports, as I mentioned. So we write maybe 17, as we can see, 70 lines of code, and those 70 lines of codes are enough to scan and to determine the open ports and the closed ports in the target machine. So I hope you guys enjoy this lesson, and I really want from you guys to test this and rewrite this from zero and add any other idea in your imagine to this code. So in the next lecture, we will talk about how we can perform a panel grabbing and the other things that we will need during any port scanning operation. So see you in the next lecture. So guys, in the previous lecture, we talked about how we can perform a port scanning using our Python port scanner. Now, I will show you how to determine the service that is working on this port. We will need Netcat to accomplish that. We need to type netcat-vv to show the purpose, to show the output, and we will enter the localhost as a destination IP and the port 22 as the destination port, and we will press enter to see that the connection succeeded, and this port is working, or the service that's working in this port is SSH 2.0 with OpenSSH software with 7.2 as a version. So in this case, we determined what is the service that is working in this port and how we can use this script that we write to determine the open ports. Then we use Netcat to know what is the service and what is the version of this service that is working in this port. So we are now familiar with how we can deal with a network connection using Python. What is the methods that we will follow to determine the open ports and to determine the service. I hope you guys enjoy this video and see you in the next lecture. Hi guys, welcome to Mastering Ethical Hacking using Python course. Today we will talk about how we can write a Python script to bypass traffic using socks. And we will talk about Tor network and how we can use Tor network to bypass the traffic. First of all, we will talk about the theory and how we can get the job done. First of all, I assume that you guys dealt with socks before. If not, I will give you a quick brief about socks. Socks proxy, it's like HTTP proxy in the same concept. HTTP proxy pass and forward the HTTP protocol, but socks pass all the TCP traffic, not just HTTP. So we can forward the traffic that is generated from our device to any other place in the internet using a SOCKS server. If we assume that this device, is our device in Jordan, and this device is SOCKS server, we will pass all the traffic that generated from our device in Jordan to this SOCKS server, and this SOCKS server will forward the traffic to the internet. In this way, we will guarantee that our real identity is totally hidden and no one knows about the main source of this traffic. So, this is the theory part, and this is the first part from this lecture. We will continue in the second part. Okay, guys, we will start this lecture by set up Tor on Linux machine and make sure that Tor is actually working on Linux machine. Then we will use socks library and we will install socks library and learn how we can use it. Then we will perform a live example about how we can change our identity. Okay, let's get started. This website will give us the real IP, that is this IP. This is the real IP that we are currently using. We will install PySocks right now by visiting this web page, which is the main documentation of PySocks library. Make sure that you install it using pep install PySocks, and then everything will goes okay with you. If you don't have pep in your machine, make sure that you install pep by downloading and execute this Python script to install pep. Okay, we will make sure now that Tor is working on by typing Tor. We can see that, yeah, Tor is already working on and everything is good with Tor. So we can use the Tor socks by using the localhost and the port 8050. Okay, we will start the coding now. We will start with the example 3 and we will import the user Python 2.7 and we will start to import socks library and we will use socket library and we will use URL lib2 library to communicate with this website and make sure that the IP is changed. Okay, we will start by setting the default socks proxy to be the Tor socks proxy here. We will use that by socks. We will achieve that actually, by using socks dot set default proxy. Yep, and this method will allows us to determine what is the socks proxy socks type we will use and the localhost and the port that we will use them to put them as a proxy, as our default proxy. Okay, we will set the default proxy and we will type the proxy. We will type here the localhost, but after we accomplish the set default proxy, we will make the socks point to default proxy and we will make it forward the traffic using the socks proxy. Okay, we will start with typing here, socks dot type proxy type socks 5 and we will make sure that the local host is the main host that we will use it with the port 8050. Okay, let's make sure one more time, socks dot proxy underscore type underscore socks 5. Yep, that's correct. Now we will use urllib2. Just we will use urllib2.url open to this. We will open this URL to make sure that the IP is changed. We will use it as rec1 equal, and we will rec print the real IP is. Okay, and we will say dot format to make format string with rec1 dot read. Actually, we will send a request, an HTTP request, and read this web page, which contains this address, and we will read it, which we will save the variable in rec1 dot read. Then we will print the real IP is and the text that is existed here, which is the IP address, the real IP is, and we will give it 0 to make a format string. Then we will make the redirect from sockets to sockets. We will use socket.socket. We will make socket points to sockets socket. Okay, socket. Okay. This line will make socket actually points to socks socket, which means that we will forward the traffic that comes from socket and the libraries that depends on, such as urllib, to forward the traffic through the socks. So we will now make rec2 for testing purposes, and we will just copy this line with some modification. We will the real IP, the socks IP is, and we will make sure that everything is working by just using these lines, by using 1, 2, 3, 4, 5, 6, 7, 8, execute the interpreter path, which means 7 lines of codes. We will use 7 lines of codes to determine that every IP that we will use it is already hidden and already being anonymous by using the socks. Let's run the script and we will show the examples. We will start the example here and we will execute the Python 2.7 example 3, and we will press enter. And we can see, oops, I'm sorry, it's rec2 here. I'm sorry. Okay, Python 2.7 example 3.py. As we can see, guys, the real IP is, and the real IP, our real IP prints out here. And after using socks, the IP goes different, totally different. So we learned how to use socks, how to use the theory that we talked about in the previous lecture. And I hope you guys learned how we can use socks in Python, and we will use socks in the upcoming lectures by using our backdoors using socks. So see you in the next lecture. Okay guys, in this video I will show you how we can jam on other Wi-Fi networks and nearby Wi-Fi networks using our Python Wi-Fi jammer, which we programmed in the previous lecture. We will type python jammer.py to make sure that we will execute the jammer.py, and we will get the jammer working on our device. This is actually my other laptop, as we can see. This is connected to isolated network, and this network here, as we can see, this is the information about this network, and this is my Samsung device, of course. After executing the jammer, we will see that this device will be disconnected from the network. Let's get started and press enter, and as we can see, the script is scanning for networks. The script determines the networks that is in a nearby and start jamming on it. We can see that, yeah, we get the connection disconnected from this device, and we jammed on the network, and all of the devices are totally disconnected from the network. My other device, actually, the other laptop is as we can see, is disconnected, so I can't make the connection with it. And in this way, we jammed on the nearby Wi-Fi networks using our Python Wi-Fi jammer. See you in the next lecture. Hi guys, welcome to Mastering Ethical Hacking using Python course. Today, we'll talk about how we can write a jammer to jam on Wi-Fi networks, of course in Python. We will find all the nearby Wi-Fi networks as the first step, and we will do that using Python. Then we will set the Wi-Fi adapter to monitor mode to can send the deauthentication packet to all networks and the clients that are connected to these networks. Okay, before we get started, we have to install some packages on some libraries, of course. Using pep, we will install Wi-Fi and wireless and SCAPI modules. We will use Wi-Fi and wireless module to can detect and communicate with the wireless devices and the interface, of course, the wireless interface. So, if you can see, guys, I installed all the packages. I hope you install them also so you can keep up with this. Okay, we will start determine the interpreter path by typing user pin python 2.7, of course. We will start importing the module. We will import wireless module. Then we will import from Wi-Fi. We will import cell method, and this cell method will help us to get all the networks using a Wi-Fi, our Wi-Fi interface. Then from scabi.all import all to import all the modules that we need to send the deauthentication packet. Okay, now we imported the libraries and the methods that we need during this lecture. We will start coding with declare a Wi-Fi 1 as an object from wireless as this. Okay, we will make sure that we will use Wi-Fi 1 later on this lecture. In the next step, we will determine the interface. The interface that I use is WLP2S0. We should get this interface using the interface or by declaring interface variable with Wi-Fi 1 dot interface to can get the current working interface. And let's make sure that interface is the same interface by Python example 4.py, of course 2.7. As we can see here, I'm working with example 4.py file, and we type the name. Let's press enter. As we can see, yep, we get the interface using Python. Now we will continue the code. We will get all the nearby Wi-Fi networks using the Wi-Fi cell method. By calling this method, we will pass the interface to this method. So this method can search for the all wireless Wi-Fi or Wi-Fi networks. Sorry, near us. Okay, we will type all Wi-Fi networks as a variable, and we will save this variable with cell.all, and we will pass the interface to it. So this method can search from the interface and get the nearby network by calling the cell as I mentioned. Okay, let's save it. And now if we print all Wi-Fi networks as a debug, we will see that, yeah, there is a cell SSID orange 0480. Now this cell or this object, we can extract an attribute from it. The attributes may be SSID, PSSID, the quality, the channel that the network works on. It's very simple. We just need to make a loop for Wi-Fi in all Wi-Fi networks to extract all elements in all Wi-Fi networks, and we will print network name. Then we will print network, for example, address, Okay, then we will print network channel for an example. Yep. Then we will print the network quality. Okay, let's make it capital to sure that everything is the same. Okay, now we will make concatenation. You can do format string or concatenation. I will concat with Wi-Fi, which is the element from here, dot the SSID attribute to get the name, then the Wi-Fi dot PSSID to get the address. Then I will get str as a string Wi-Fi channel. Then I will make also concatenation str with the Wi-Fi dot quality. Yep, everything is working on now. Hop that. We will test the code, but let me do a quick revision on that. We made a great progress for now. The revision will be in the 7 and 8 lines. As I mentioned, we declared a wireless, or we create a wireless object, Wi-Fi 1, and we extract from the Wi-Fi 1 the interface that we are working on currently. Then we imported the cell method and passed the interface name to extract all the Wi-Fi networks, and it's stored in all Wi-Fi networks. Then we do a Wi-Fi or for loop to extract all Wi-Fi networks, and we declared Wi-Fi as an element. From this element, we extracted the SSID, PSSID, and the channel and the quality. I hope this code is working now. We will test that. Okay, Python 2.7, example 4.py, and we will press enter. Okay, oops, I'm sorry. Okay, I forget that. The address here, not PSSID. The address should be PSSID, and here the SSID, for example, and PSSID. Okay, we will run the code, and as we can see, everything is working fine. We extracted the orange network, Wi-Fi network information, SSID the name, PSSID the address, and this is the address for this network. We will use the address to jam on this network on the next lecture. I hope you guys get this lecture good, and you get the code and get the main concept. See you in the next lecture. Okay, guys. As you can see, I added a piece of code to the code that we wrote in the previous lecture. I will explain this code. I see that explaining this code instead of writing it from zero will be much better to you to understand the main concept and the main thing that will happen when we send the deauthentication packet using the SCAPI library. I just make a small change on the previous code. I added an append operation, and I declared a list to add the addresses that we will use them to jam on the networks. So this is the code after the editing. This is the previous code, and this is the code I just add. This code is a very simple code. We will look at that we declared a function named jam, and we will give this function an address, and this address will be the address in this list to jam on it, to jam in all nearby networks, not on just one address. So we will here put the monitor mode card, which we will I will show you guys how we can put an interface in monitor mode. I connected to my other machine that we will perform the authentication attack from it. If we type iwconfig, we will see that we got two cards, WLAN1 and WLAN0. We will use WLAN1. We will change the status of WLAN1 from mode managed to mode monitor mode. Okay, we will use a small command using ifconfig WLAN1 down. Okay, now we will use iwconfig WLAN1 mode monitor to make sure that we are changing the mode for this card from managed to monitor. As we can see, if we type iwconfig, we will see that we changed the WLAN1 from mode managed to mode monitor, and we did it correctly. Now the last step or the last code in this script will be the jamming code, which is the most important code. We will declare a function named jam, and we will pass an address for it. Now we will put the monitor mode interface, which is the WLAN one. Then we declare the PSSID as an address. We will use the address as the PSSID variable. The client, that means we need to broadcast the packet we will send to all the clients, to all connected clients, to make sure that we will disconnect them from the network and tell them that, hey, I'm the network and I want to disconnect you from my network, so please disconnect. That is the script that we will do it, and we will see that this script will really works on in this case. Now we will declare the variable count with the 3. This is the how many times that I want to send the packet, the deauthentication packet. I will declare it here to the host. Conf.verb equals 0. This is a scapy variable, and we declare that using the conf. As you can see, the configuration iface, which is the interface I said, the WLAN one, and here the conf.verb equals 0. We configured this variable for scapy. Now we declare the packet using radio tab from scapy library, as we imported it from here, using also the conf, of course. Now we declare the packet using radiotape.11, and I can't explain this code anymore to you guys. You need to write to read more about scapy, and I want from you to write a pref about scapy and send it to me, especially about the .11, to make sure, guys, you are familiar to this. And as we can see, we passed the required argument to .11, such as the subtype, that we declared it as 12 that used as a subtype. You can read more about it. The type equals 0, the address 1, which is the broadcast that we did, address 2, the PSSID, and address 3, the PSSID. That's the first component of the packet, and we make sure that we used the authentication packet with the reason equals 7. That means that we want to create a packet which with this specification to send this packet to all the networks. Then, as we can see, for n in range and count, we created a list with the element of count, which is a 3. So we will send the packet 3 times in a sequence way, of course. So we will print later on, print deauthentication, the number of the deauthentication packet, and sent via which as the interface that we determined to the PSSID, to the address, and for the client that we declared, and the client, of course, is a broadcast. So we will send this packet to all the clients that connected to the network, and we will say to them to cut the connection from the network. And now we will write a while loop, and this while true is an infinite loop. This infinite loop will make sure that we will extract each PSSID from the PSSIDs list, which we created here. Then we will print jamming on the status that we are, or the status of the PSSID will printed here, jamming on. That means we are jamming on the PSSID, which is we passed, or we will pass it to jam function. So you can see that we will pass the PSSID address to the jam function, so it will create all these things. Then we'll send the packet, and we'll just repeat that in an infinite way to make sure that we will jam on the networks in an infinite way. If you want to cancel this, you just have to Control Z to cut or kill the process directly. You can manage this way by making a key an execution way, or sorry, in the execution by typing a way to execute that. This is not my point here. I want to make sure that everything is good, and I hope, guys, you let's say get okay with this code. I know it's just they're a little complicated, but I really enjoy that while I was writing it. So I hope you guys enjoyed that also. So in the next lecture, we will run the script in a real-world network. See you in the next lecture. Hi guys, welcome to Mastering Ethical Hacking using Python course. Today, we'll talk about how we can handling URLs using Python. In this lecture, we will talk about how we can send HTTP requests and how we can parse the HTTP response, and also how we can extract the request's headers and how we can add a customized header to any HTTP request that we will send from Python. And we'll talk about much more than that. Okay, let's get started. We will talk about the first page that we get here as an example for us, which is the example1.html. As we can see, this is a normal web page. We have a tag h1, header 1, we have a header 2, and we have, of course, the centered text. Okay, we will make sure that you set up, guys, the proxy. I set up the interception proxy per proxy to see and to intercept every single request that will pass through our proxy, which is configured at this address. I will make sure that I configured it using export, HTTP proxy equals HTTP localhost 8888 to make sure that the terminal will use this proxy by when we will pass any request from the terminal. Okay, now we will start typing Python, and we will import URLlib2. URLlib2 is a great library to communicate with URLs and to send requests and parse them. We'll press enter and we will create an object. Rec object, for an example, equals urllib2.urlopen. URLOpen method helps us to open a URL, and we will give the URL open this URL, for an example, and we will paste it. Let's open this just the perp to make sure that the idea will be clear to you guys. When I press enter, I will see that the perp proxy intercept a connection and intercept a request. And we can see that request is a GET request to this path to this host with this user agent, which is the URLlib2 request. I will forward that to make sure that everything is good. And as we can see, Python interpreter passed it, and we don't have problem with that. If you want to know more about the rec object and how we can use it, we simply can type dir rec to see the methods and the variables that we can use. As we can see, we have great things here. We have a read. We have read line, read lines, MSG, message, next, and headers. And get URL, get code, of course. The first thing I want to show you guys is the code, which is the HTTP code of this request. If we go to Chrome, to this page, I can see the details of each HTTP request, and I assume you guys know about them. If you're not, you can visit this page and you can know more about the HTTP codes and HTTP status codes, of course. Okay, if I want to know what is the code that this URL returns to me, I will just type rec.code and I'll press enter. As we can see, the request returned for me 200 code. If we looked for the 200 code, we will see that the request has succeeded and everything is good. We send the request to the server, and the server returns 200 for us because everything is good. The directory or the page that we requested are really existed, and everything is working great. Okay, we will read and parse the. First of all, we will just read the request. We will parse it on the next lectures. We will read this request by type rec.read as a method, of course, and we will say that we have this content with it, of course, in its HTML code. If we just compare between this code and what we returned, we will see that we have the exact code that we get from the Python. So let's just do that. As we can see, the title with the example one, we have the h1 high. We have the this is an example of a page with the h2, as we can see, and we can see that we get the centered text. Okay, we will talk about how we can parse the response of this request, and how we can deals with headers, and how we can deals with every single detail in the request in the next lectures. Hope you guys see this video good, and hope you really enjoyed this video, and see you in the next lecture. Hi guys, in this video we will talk about how we can write a very simple Python script to test an authentication system that's written in PHP. I wrote a very simple authentication system using PHP, which takes two post requests, the first named username and the second named password, then compares them with an existed and hard-coded values, with the username equals Askar and the password equals from 1 to 9, and will check. If that values are correct, we'll print login success, else we'll print login failed. We will use URLlib2 and URLlib library to accomplish this operation. So we'll start coding. We will set the Python interpreter, then we will import URLlib2, and we will use URLlib library, just URLlib. We will import from URLlib import URL encode. Okay, the URL encode method allows us to convert the dictionary to a query string, which we can send this query string as a post request. We will define a variable, declare a variable named encoded, or just data, and this data will be a dictionary, which is include, okay, the first key will be username and the password will be Askar. The value of this key will be Askar, then the password key will be with a value from let's say the first time Askar. Okay, now we will encode this data, so we will see data encoded or encoded data. Okay, we will use URL encode and we will pass the data to it. Just we will print it to make sure, data encoded. Okay, we will print the script. Now we will Python. Okay, as we can see, we will pass the data as a query string, username equal Askar and the password equal Askar. We will send this query string as a post to the server or to the authentication page. We will change the password to, let's say Askar, for an example. Now we will make sure that we will prepare the request that we will send to the server. So we will type rec URLlib2 dot request. We will deal with a request method. We will pass at the page that we will send the request to it, which is in this path, order.php. Then we will pass the encoded data, which is the data encoded variable. Then we will pass any headers. To show you guys how we can edit a headers for a request, we'll use headers equals, for an example, the first value will be a user agent and the value will be scanner. So the first key, which is the header name, will be user agent, and the header value, which is the value, will be scanner, as a dictionary, of course. Now we will send this request, and we'll declare a final request equal rec dot open, and we will send the rec. So we will open, or sorry, URL open here, URL lib2 dot, I'm sorry, just URL lib2 dot URL open, and we will open the rec. So we prepare the request at this line, and the request will be sent to this URL, and will post the data encoded, which we encode using URL encode, and we pass this dictionary for it, of course. Then we will send it with the special headers, which is user agent scanner. Now we will send this data, and we will print the response that will comes from the server. Okay, let's say Python example5.py. Okay, as we can see, it's passed through the proxy. We can see that the post to URLs auth.php sent to the host, which has a content type application xwww form URL encoded with the user agent scanner, and of course with the valid username and the password with ASCII and ASCII. And we will forward it to see that, yep, the login failed message, which means, of course, that the username or the password are incorrect. So we will just edit the username to be, or the password, sorry, will be from 1 to 9, and we will resend the request, and we will see that, yep, it's changed. We will forward it, and as we can see, we got the login success message, which means that everything is good and the username and the password are correct. Now I want from you guys to use a for loop to read read the password from a file, and each password you need to encode it and send it to the URL. So this is your exercise for this lecture. I hope you attach this or send this exercise for me, and I will check the your script for you, and I will give you any recommendation to do it in a better way, or if there is any notes, I will definitely send it to you guys. So I hope you enjoyed this video, and see you in the next lecture. Hi guys, in this video we'll talk about how we can write a Python script to communicate and control a web shell. I wrote a very simple PHP shell, as you can see. This script takes a GET request named cmd and store it in comment variable, then execute it and print the result. As you can see here, if I typed cmd equals, for example, pwd, as we can see, pwd, this is the comment that we use, and this is the result of executing this comment. We will write a very simple Python script to execute a command on a remote shell and return back the result for us. Okay, that's very simple script. We will use, of course, Python, and we will use the URL library to communicate with this shell. I will start by determining the Python path and importing url-lib2 and sys. Now we will take the shell path, or the full shell path, as a first argument from the user. So we will declare a variable named shell equals sys.argv1, the argument value number 1. Then we will make while loop true, while true. We will take the comments that we want to execute every time from the user. So for that we will use the while loop, and we will give it a true to make sure that we will make sure that the script will run in infinite way and start executing every comment that we send to the Python script. Okay, now we will declare comment equals row input, and we will say shell, for example, at host. We will replace the host later, no problem with that, and we will make sure that if we print the command Everything will be okay. I will quit, okay, to make sure that, oops, I'm sorry, opt course example, okay, Python 2.7, example 6.py. Oh, oops, okay, for example, anything like this, okay. If I said pwd, I can say that we printed the command that we entered using the row input command. So everything is good. Now we will continue coding. Make sure that I stop this, clear, okay. Now we will make such as a concatenation between the shell path, which is this, and the argument that we want to send to the host as CMD parameter. So we'll use that using rec1 equals, and we will make sure that we will enter the shell path, or sorry, like this. Then we will enter CMD equals the command that we want to send to the host. Then we will say format, then shell and command. Very good. Okay, now let's print rec1. Make sure that everything is good. Python with that example pwd, as we can see, yep, we can send the argument with the path shell that we want to send the command to it. If we want to test it, we will take this and say clear. Okay, Python example 6.py, the full shell path, and we will press enter. Now, if we print, or if we send pwd command, sorry, and press enter, we will see that, yep, we will send that command, and the command or the request is ready to be sent to the server. If we copy that and paste it in the browser, we can see that, yep, we get the result. Now we have to send the request and read the response that will comes from the server. So everything is good. Now we will start by request equals urllib2.url open, and we will open the rec1. When we send this request by using URL open, we will print the request dot read, which is the response here. If we said that server response, okay, to make sure that this is the response that we will read from the server, which contains this text. Okay, I will just make a very simple edit on this script. I will just make this point to the real host name, which is this. I will simply add this, I'll copy this path and go to Python interpreter, profile Udemy, okay, Python 2.7. I will declare a variable with name host equals, that's good. Now I want to get this host name just without anything else. I need to use split method. I will say host.split, then I want to declare something to split the string on it, and I will use this slash. And if I execute that, I can see that, yep, I get a list with an element, and we will take the second element. If we say the second element, we can get the host name. So that's good. Now we will declare host equals shell.split. We will take slash, and we will take the element number 2. Everything is good. We're now good to go. I will test the script, and Udemy, of course, here. Clear Python 2.7 example 6.py. We'll make sure that I copy that address, and I'm ready to execute the script. I will press enter, and oops, forget to save that. Oh, sorry. Host, I will replace this host with 0.format the host, of course. Make sure that everything is good. Okay, Python, yep, everything is good. As we can see that the shell at the host, we don't have problem. We can execute pwd, we can execute ls for a command id, and we get the response without any problem. But I have a little problem with this code. If I send a command with an argument or with an option, I will have a problem with that. Let's test the ls minus la. As you can see, I get a bad request. I will get this request because I don't have any encoding on the URL or on the request that I sent to the server. So I need to make sure that I will replace every space in this line. If I just tested ls-la, I want to make sure that every space is replaced with the percentage to 0. So I will use the replace method in the string. I will say string to make sure everything is clear. I will simplify the string dot replace. I will replace this space, okay, with the value percentage to 0, which express, of course, the space on the URL encoding. Okay, we're good to go now. If I run the script, I will see that everything is good, and I get the host, I get the shell. If I say your ID, for example, if I got the ls minus la, I will get, of course, the comment that I want, even it was with an argument or with an option, of course. I can execute uname-a for an example, and I will get every single command I executed without any problem. Okay, now you can make your own customization on this course. You can verify or validate the sys.argv path. You can make sure that this URL, which is the shell, is existed on the remote server, and so on. You can also make some special commands like exit, like open, for example, read on the while loop, which is control the command and the data flow on it. I will let you guys edit and customize this script as you want. I hope you guys enjoyed this video, and see you in the next lecture. Hi guys, and welcome back. In this video, we will talk about how we can write a Python script to perform a web dictionary attack. The web dictionary attack is very useful when you want to detect any files or folders on a remote host. And we will learn in this video how we can write a Python script to accomplish that. Mainly, we will depend on the HTTP response code or status code. We will make sure that every request that we send will returns a response code or a status code, and we will make sure that we got 200 response codes to make sure that this file is on the web host or on the web server, of course. So if I requested a file and this file is existed on the remote server, the server should returns 200 to me. If not, of course, is not found without, and the request goes without any problem, the server will returns to me a 404 error message. We can see here the 404 not found. We will make sure that we will read the returns and the, of course, a status code that will the server return to us to make sure that everything is good with us. Okay, we will start coding, and we will start by determining the Python interpreter. Then we will import the URL lib2 and sys libraries. Then we will make sure that we will declare host equals sys.argv1, which is the argument number 1 from the host, from the user, of course, and we will store it in host. Then we will declare a dfile variable, which is the sys.argv number 2, which is the dictionary file path. As we can see here, I made a very simple dictionary, which contains simple paths like administrator, file.php, data, dashboard, CGI pen, admin, and check.html. We will check each entry and make sure that we will get the 200 response code to make sure that this file is already existed on the server. Okay, now we will start reading the D file and make a loop to read each line on the file. So we will declare another variable which names data equals file, or sorry, open. We will open the file with a read mode. Then we will file data if data equals data.read lines to make sure that we will read the file line by line. Then we will make a for loop to read each line in the if data. This is a list, of course. This list contains every line in the file which we opened by or we entered via d file and opened via data. And now we will for line, for example, in f data. We are now ready to print line. And if I run the script, Python example 7.py, will enter the localhost, for example, and I will enter the dirs.txt. As we can see, I got the entries of the file, but I have a problem. And this problem, because I get a line terminator here, I need to strip this line terminator. I can use that by strip the \n, which is the line terminator. I can Python now, and everything is good. We can see that I read each line without any problem and without the line terminator, of course. Okay, now we can just line without n, for example, line wn, to make sure that this line is without the \n, without the line terminator, and we will use it during sending the request and, of course, printing any results. Okay, now we are ready to send the request, so we will declare a variable name strrec, which is the string request, and this string request we will send the host / the file name, and we will format the host and the line wn, which is the line without terminator or without line terminator, and we are now ready to send the request. We will use rec variable with the URL lib2.url open and, of course, strrec. But before that, I will make sure that everything is good, and I will print each request to make sure that yep, everything is good. As we can see, we will request localhost administrator file.php data, etc. Everything is good, and I'm ready to send the request now. Now we will make a try block to make sure that we will send the request without any problem. And if there any problem like 404, which is not found, 400 bad request, whatever it was the code, it will return via the exception that we will make in the next line. Now we are ready to say that we will just move this here. We will try to send this request. Now we will make the compare f rec.code equals to 200, which means that we found the file. Just print that for us. Print, here we can do this. 0, 1 is found. We can make it 200 here. Dot format, of course. We will give it host, and we will give it the line wn, that the line without terminator, which is the file name actually, and we will accept. Of course, we will print anything, or I will tell you something. We can just pass this to make sure that we will print only the founded path in the or the found path, in the request or in the remote server. So we will send the request here, and we will make sure that the code of this request is 200, which means the file or the folder is existed. Then we will print a message that shows that this file is already existed on the web server, and we can browse it without any problem. If any problem happened with our code, that will make an exception, and we will pass and continue the workflow without any problem, or the code execution, of course, without any problem. Okay, we're ready to go now. I will Python the script and press enter, and but I have to remove that to make sure that everything is clear to you guys. Okay, now I will press enter. As we can see, I get the all folders with the 200 response code, which means that this files or folders are existed in the web server, on the remote web server, If I try to open the administrator here, I will copy it and paste it. And as we can see, yep, I get the administrator, and this is a valid directory on the web server. I'll try file.php for an example. That will send file.php, and as we can see, yep, file.php is existed on the server, and I can check admin to make sure that, yep, this directory is valid on the web server. So in this way, or in this technique, actually, I can write a very simple web directory script to perform a web dictionary, attack on any web host or in any web server. So hope you guys enjoyed this video, and see you in the next lecture. Hi guys, and welcome back to Mastering Ethical Hacking using Python course. Today we will talk about Python shells. And in this lecture will be an introduction to Python shells, of course. We will use Python shells to executing commands in the remote machine. The shell helps us to controlling systems and escalate our privileges. And of course, we write in Python so that our shells is easy to write. We will use socks, sucats, and other libraries to accomplish what we need from the shell. There are two types of the shell. The first type is a reverse shell, and the second type is a bind shell. The reverse shell, when the compromised machine and the shell try to connect back to the attacker machine, of course. In this case, we have a backdoor or a shell on the compromised machine trying to connect to the attacker machine on a specific IP address and specific port. When the Python backdoor tries to connect to the attacker machine and establish the connection, the attacker can now executing the commands and send back the commands to the compromised machine. The bind shell. In this case, the attacker connects to the compromised machine, which means that the backdoor will open a port in the compromised machine and start listening on it. In this case, the backdoor or the shell listening on port 444, and the attacker machine will try to connect from his machine to the compromised machine on this port and this host or this IP. Mainly, this is the methods that we will try to implement in Python to accomplish what we need from the Python shells. So, see you in the next lecture. Hi guys, and welcome back. In this video, we will talk about how we can implement the reverse shell in Python. In the previous lecture, we talked about how the reverse shell works, and we talked about that the shell connects back to the attacker in a reverse shell method. So, we will program a Python script that connects back to the attacker and start receiving the command, then execute them, and returns back to the attacker machine with the results. Okay, I will start coding, and I will start by determine the Python interpreter path. Then I will import sucat and sub process library. We'll use sucat to communicate through TCP, of course, and sub process to execute the command and send them, and of course send them to the attacker, and sucat, of course, to deal with TCP as I mentioned before. Okay, now we will declare host as my IP, which the script will connect back to it, and the port, of course, with port 8888, and I will initialize a socket with variable sucat dot afi underscore inet sucat dot sock stream to make sure that we will use IP version 4, and we will use of course TCP protocol. Then we will connect to the host and port. We will use sock.connect, and we will enter tuple with host and port. Okay, everything is good. Now we will make the connection with the attacker machine. I will make sure that everything is good, and I will, of course, this is my IP. Yep, 17. Okay, netcat-vlp. I will use netcat to listen on specific port, which will be 8848. Okay, now I will use second terminal to Python example 8.py, and I will press enter. And as we can see, oops, I have a problem here. Oops, sorry, I forgot to save it. Okay, as we can notice, the connection comes from the one, which is the local host, of course, 182.168.1.7, which is the local host, and I connected to this port using the couples of lines that I wrote. We don't have problem with that. We talked about that in previous lecture, so everything is good so far. We will start sending the comments and execute them. So while true, we will use this for the comment. We will receive the comment. So the comment will be sock.receive. We will receive first 1024 character from the socket. Then we will use the subprocess, or we will pass the comment to the subprocess function to make, or library, sorry, to make sure that this command will be executed without any problem. So we will initialize a variable with a proc, for example, proc with this process. Then we will start using subprocess.popen, which is the method that we will use. Then we will pass the command, of course. Then we will make sure that this command will write in a standard output, and we will read this using the piping from the terminal, then send it back to the attacker using sockets, of course. So we'll use stdout equals subprocess.pipe, and we'll use stdr equals subprocess.pipe, of course, and we will make sure that the shell is true to execute the things that we wanted without any problem. Now we will read the result of executing this process using proc for result. For example, we will read the std output using proc.std out.read, and of course the proc.stderr.read to read the command result, or the execution result from the subprocess or popen function, of course. Then we will send back sock.send. We will send back the result, the proc result back to the attacker. Okay, everything is good. We will have to make sure that everything is working fine. Oops, sorry. Okay, we are working now. And if I connected to, sorry, forget this. Okay, if I connected now, or if I run the example a.py, which is the reverse shell, I will receive a connection from Netcat that tells me that someone has connected to this port without any problem. I will try to run the script, and we can see that, yep, we get a connection. I will send a comment, which is pwd for an example, and I will press enter. And as we can see, in the Python example a.py, I didn't receive anything, but in the background, I received the pw command. The pwd command stored in the command variable. Then I opened or executed the command using subprocess.popen, and I read the result of the executing of this command. Then I send the result back to the attacker. So as we can see, here I sent the pwd, and I received the result of executing this comment. I can make a very simple edit on this script to make sure that everything will be clear to you guys. I will make here put a little text to result of executing command, and we will comment here is, and we will put the one, and we will dot format. We will format here proc as second value, and the first value will be the comment, and we'll press save. We will make sure that we are listening. Okay, Python, we don't have a problem with that. PWD, and as we can see, when I send the PWD command, the reverse shell returns result of executing command PWD as and result of the value of the command, sorry, that I sent, and this is the value of executing the command. So, hope you guys enjoyed this video, and see you in the next lecture. Hi guys, and welcome. In this video, we will talk about how we can write a Python rootkit that is invoke a reverse shell with a hidden process. The main idea that we will implement in this video is how we can hide the process ID for any process that we want. Offshore in this case will be the process of the rootkit that we will program. This rootkit, as we can see, is a very simple Python reverse shell that is invoke a connection between the host and the attacker, or the target and the attacker, sorry, and receive the commands without any problem. Then check if the command equals to exit, simply close and exit the socket, else it's just going to p open and enter a new command and save the result into proc underscore result, then send the result of the command that you send. But I just did some modification to this code. I define a function. This function, as we can see, its name make connection, that takes two parameters. The first parameter is h, and the second parameter is p, host and port, of course. Then we try to connect every 5 seconds. We will, at every 5 seconds, we will connect back to the attacker machine. And this is the first change that I did to the code. I made a very simple change here, and another line of codes I added here. I will talk about them later, but the main thing I did to the connection progress is that I waited 5 seconds for each try to connect to the host. Now, if we invoked a Netcat listener, as we can see here, Netcat, the VLP, and we will listen to port 8888 48, and here we will Python rootcat.py. We will run the rootkit. We'll see that we get a shell after 5 seconds. As we can see, yep, after 5 seconds of launching the rootkit, we have a reverse shell, and we can simply communicate with it and start executing the command without any problems. I can see I can execute ID, uname -a, whatever I want. I can simply type exit to close the reverse shell, or to close the script that I wrote. For now, it's not a rootkit. The rootkit that we will program is a rootkit for a process hiding. We will hide the process here, and we will write a very simple rootkit that have a one unique operation, which is, of course, as I mentioned, the hidden process. As we can see here, if I just invoke the Python rootkit.py, if I execute that, if I try to use PSAUX and make a grep, or before that, we will just launch PSAUX. As we can see, we have all the running process on my machine. And as we can see, we have one here with name Python rootkit.py, which is already running, and with a PID 11752, we can just kill this process using 11752. And if we press enter, we can see that we killed this process, and no more shell. If we try to connect or listen, to the port, we can see that we don't have any reverse shell coming because we killed this process. And as a system admin, that good system admin actually watch the process continuously, and trying to find any suspicious process. We can use another tool, which is htop, for example, to manage all the processes, and we can see that every process that's working on the machine, we can find it. We can find all the processes that already working on my system. And of course, we can see that we have a lot of already invoked processes on my device, which if we see that, you can see every detail about it, the process ID, user, and the command that it's already executed. You can see every command and every process that it's on our system. If any system administrator detect that and try to search for the process, he can search for your process and see that this process is doing something not usual, something is bad to us. Okay, so if we just try to actually top again, we have the processes here. If anyone search for the process, you can find it and simply you can kill it. Or maybe to, let's say, analyze it, and from any process analysis program and monitoring, of course, process monitoring, you can see that this process is not usual and this is a suspicious process, and you can simply kill it without any problem. So we will learn now how we can write a very simple technique that allows us to bypass this security or the process, and make our reverse shell undetectable by the process management tools and work as a hidden process. Okay. I added a few lines. As you can see, our first thing I imported is a string library. Then I imported the random library. I imported as an R, and now I declared variable named sh that contains the characters with uppercase and digits. I will just move the digits here, or we can use it. I will remove it later to show you guys what's the main purpose of using uppercase and digits here. Now the token is randomly generated character from the uppercase and the digits here. We can, in my example, I use 772, but I just will decrease them to use 5, just to 5 character. We will generate a 5 character here. If I copy this and go to Python interpreter, Python import random as our import string, and I do that, we can see that the token, each time the token is different. We will invoke the token with a random strings. We need the random strings to create a temp file. And we will make the temp file to make sure that we will, let's say, perform a mount binding. You can know more about mount binding and read more about the mount binding, because mount binding is the main technique that we will use to bypass the process from being monitored. Okay. I will explain the main technique for you before I go to code again. Now, every process should be here in this process information, of course, should be in this path, proc. As we can see, if we go to root directory, and if I took a root actually, okay, if we list all the directories and files, we can see that in the root directory we have a proc here. Where is it? Okay, proc. The proc here is a directory that contains every single process that is already working on your system. As we can see, if we just list all the processes, we can see that every process has the PID, right? And this is the PID for each process. Now, if you close or invoke a new session, you will invoke a new process, you will notice that we create the system create another directory with another ID or another number, and this number is the process ID for this number. If we try to do that, now I will just kill this and rerun it. I will test the psaux grep python rootkit.py. I can see that the rootkit.py has a 11914, and this is the process ID for my Python rootkit.py process. If we go here and try to enter 11914, I think, yep, I will notice and I will see that we entered to this directory, and if I make ls, I can see the main information and the main files that contains the information of this process, and I don't have a problem to list them and to read them. Actually, if I try to read the cat.io, I got this information, but the main idea here that I can't remove any file of them and I can't edit any one of them. As we can see, just we have the write and the read as a root permission, of course. So we need a technique to hide this directory from the process management. So if we hide this directory, in PyLogic, we don't have a process because we hide this process ID, and the process management tools can't access it because it does not exist, or if it's empty. So we will perform a mount binding on this directory to make sure that we will we will mount an empty folder into this process, which means that we don't have any information for this process. And that's mean we don't have any process will appear here if we just try to use any process management tools. Okay, so the mount binding, we can perform the mount binding by using the mount -o bind, and this is the command that we can use it actually. And of course, we need to be a root to execute that. The mount bind here, we will create a unique directory, an empty directory, of course, and we will give it a name, and the name will be the sh, which we the token which we generated from the sh variable using the r.choice, which is random.choice. Then if we, for example, if we just generated ddd for the process 11914, I think, yep, 11914. If I press enter, we just make here, we have to make the temp ddd, then we have to make the mount. Now, if I just back to psaux-rootkit.py, I can see that I hide the process without any problem with that, and we don't have a process ID here or PID. And as we can see, we still have the shell here, or the rootkit.py executed. And to make sure that everything is okay, I can re-listen to this part and wait for 5 seconds. And as we can see, we got a shell. And if I execute ID for an example, uname-a for an example, uname for example, I can get the result of executing these commands, and I don't have a problem with that. So we can say that if you want to hide a process ID, you have to make a mount or bind mounting to this process ID. you have to create an empty directory. Then you have to mount this empty directory to the process ID directory, which is in the proc ID or the proc PID here, as we can see. So in this code, actually, I get the current process ID using the os.get PID, and we can see here if I go to Python and imported the OS library, then I try to PID os.get PID, then I execute it. PID, I get the current process ID, which is 120404. Sorry, 12040. We don't have problem with that. Okay, now if I try to kill here the process by myself, of course, and I took a root privileges, I want just to make sure that you know, guys, that the Rootkit, it's a tool that you use after you gain or you have a root access or a root privileges. So in this case, you can launch the rootkit, and as we mentioned that you need to be a root to make a mount into a process. So you have to be a root to use this feature actually. Okay, to make sure that everything is good, we can just try to make a mount here. Mount, or sorry, we have to make dir temp ddd1, for example, and we will mount -o. We will go to the temp ddd1, and we will go to any process ID. We can get can just run any process. We can just get the PSAUX. Then we can take the Python 12040. Okay, 12040. We can press enter, and as we can see, only root can use the options mount option. So we need to be a root to run this rootkit without any problem. Now, if I just try to Python rootkit.py and I press enter, and I will start a listener here, netcat vlp. Okay. I can see that I received a connection, and if I can type ID, I can see that I get a root permissions. I have a root here, or root privileges. Sorry, I can see here that I got another thing. If I try to psaux grep rootkit.py, which is the file that I executed before. If I press enter, I can see that I don't see anything is related to rootkit.py. Of course, this is for grep. This is the process that I just used. It's not the execution of rootkit.py. And as we can see, we get the root privileges without any problem. We just run the rootkit using Python, of course, and listen for the port that we want, and we made a very simple mount binding into the process ID to make sure that everything is good. So hope you guys enjoyed this video, and if you have any question, just send it to me and I will be happy to answer you guys. So see you in the next lecture. Hi guys, and welcome. In this video, we will talk about how we can program reverse shell, but for Windows platform. I want to notice you guys that we can use this example to attack Windows machine. But later on this course, we will know why we will use the OS library instead of using subprocess. I will tell you why in this stage actually, and I will explain that later on next lectures. The first issue that will face you if you use subprocess on Windows and convert the or the Python script to exe, that if you use the subprocess library will cause a problem. There's a problem with subprocess when we use it actually with PyInstaller or Py2xe, that will cause a problem actually. Sorry. So instead of using subprocess on Windows, I will use the OS library, and of course you can use it on Linux, of course, but just to explain multiple techniques to you and to make sure that you can draw a simple tree, and from this tree you can know where to use the best Python script for your case. So if you use Python, or sorry, if you want to target a Windows machine and you are using Python and you want to create a portable executable or exe file from your reverse shell on Windows machine, I prefer that you should use this technique when we use OS library to do that. OS library, then we will pass the popen, then we will print each output that we will get. Another technique, we will talk about it in the previous or in the next lectures. Not a one lecture, actually, maybe we talk about it in 2 lectures, but we will talk about another technique that we read from os.popen directly. We just use a read method. I don't want to confuse you guys, but if just we to show you that, I'm sorry, but I have to change my IP here. This is my IP. I will listen to port 1337. I just copy this and go here, reverse shell, CLS, okay, CD desktop. Now reverse shell.py. If I run this script on Windows machine, I will get a fully functional reverse shell without any problem. And also, if I use the sub-process version of my reverse shell, when it depends on sub-process. But the main problem, again, I will tell you again that the main problem that we will face it will be with sub-process when we convert the script or Python script to exe. So instead of using sub-process, I just use popen, and we will use popen in multiple techniques later on. So I will press enter and I will go back to my attacker machine here. And as we can see, we got a connection from this address. If I just make a simple command like who am I will get the result. If I executed dir, there of course I will get another result from my machine. Hope you guys enjoyed this video and hope you really get the main idea from using OS instead of using sub-process. And as I mentioned, we will talk about this later. So see you in the next lecture. Hi guys and welcome. In this video, we will talk about how we can implement a Python bind shell. In a previous lecture, we talked about how we can implement a reverse shell. And we talked about that in a reverse shell situation, we let the compromised machine connect back to the attacker machine. But in the bind shell situation, we will connect to the compromised machine and we will connect to the bind shell and start communicating and start executing and receiving the commands. So in the bind shell situation, we need to run the bind shell script on the compromised machine. Then we need to connect to the compromised machine. We will not let the compromised machine connect back to us. So this is a very simple situation. This is a very simple code actually. We will start writing this code. We'll start, of course, by determining the Python interpreter here, and we will import sucat and os library. So we will actually define another variables, host and port, the host that the bind shell will listen to the connection to it actually. And for example, would be the local host, of course, to listen on the port on the local machine. Then the port will be 2000 for an example. Okay, now we will start socket initialization. We will equals socket.socket, and the socket.init if init, then the socket.sock stream to use IP version 4 and TCP, of course. You can review the previous lectures to know more about socket initialization and the sockets or Python sockets. Okay, now we will use a bind method. You can read more about the bind method and the related method to bind method. We have except here we have a listen. You can read more about them, but the bind socket mainly, it's a method that you pass the host and the port that you want to listen to, and it will open a port in your system and start listening to any incoming connection. Then you use the except method to deal with two main variables or main pairs, actually, as they mention. The first pair will be about or be responsible about receiving and sending data, and the other pair of the tuple we have here will be the address, which is determine the pound to the socket on the end of the connection, and we will see that later on. So we will pass the socket.bind here. We give it a tuple. The first tuple value will be host, and the second value will be port to listen on the local host on port 2000. Of course. Now, you have to remember this port because you need to connect back to it later. Now we will listen, sock.listen. We want to listen, for example, for 100 connection, and you can know more about socket.listen, and you need to read more about the socket.listen, and it's the number of connection you have to deal with it. The Python documentation is very, very important to you, and it's very useful, and you can read it, and write any notes that is related to this topic and any other topic actually in the course. Okay, now we are listening. Now we will start a loop, and this loop will just accepting any incoming connection. So we will say while true, and we will now declare the two pairs that we read about them. The first pair will be client, and the second will be address, which is the client will be responsible about receiving and sending the information between us and the client. The address will be the main system boundary, as we can see the system pound, socket.accept here. We can read that the address is the address pound to the socket. On the other end of the connection is just an address to know what is the address boundary or what is the address that we are dealing with. We don't need to know more about the address in our situation. So here we will initialize the socket.accept, and we are ready to accepting connections now. When any connection, let's just begin from here. Now we will listen to any connection. If any connection established here, we will start another true infinite loop, and we will start to receive the command. The command will be client.receive, because we talked about the client, and we talked that the client is the variable, the object is responsible about sending and receiving the information, or handle the communication between us, and the command is the variable that we will store the first thing that we will send from the attacker's machine to the compromised machine. Then we will store this data to the command, and we will store we talked about the receive method, and we talked about the number of the bytes that you want to receive. We don't have problem with that. So now we will identify or declare another variable named result, and in this variable we will make a very simple call to popen os.popen library or method from os library, of course, to execute the command. Then we will use read method to read the execution result of this command and store it on the result. Now the final thing we need to client dot send the result, or the final step actually. So we receive the command here. We establish the connection first. Then we receive the command. We stored it in the command variable. We executed the command that we received from the attacker on a result variable. We passed it to popen. Then we read it, and then we store it on a result variable. Then we send the result back to the attacker. Okay, this is the technique that I talked about on a previous lecture. We talked about the popen, and I show you multiple techniques to use popen from OS library. Actually, this is a very simple and maybe the best technique that we will use on executing commands on a system. So everything is good. I will save the code and example 9.py. I will Python it. Example 9.py. I will run the script. The script is now running. I will connect to it. Now Netcat purpose to the 2000. Sorry, this is the 2000, the port 2000, and the host address. And of course here I, as we can see, started the Python example 9.py script. Now is listening on port 2000, and when I press enter, as we can see, yep, the connection succeeded, and there is a connection happened with my Pine shell here, and now I can transmit the command that I want to send to the system, and the system will get back the result to me actually. And if I who am I will get Haskell uname-a. I will get the result. If I get ID, I will get the result too. ls and pwd, any other system or any other command on the system, I can execute it without any problem. So hope you guys enjoy this video, and hope you guys really get the main concept of this technique and the Pine shell technique, and see you in the next lecture. Hi guys, and welcome. In this video, we'll talk about how we can protect our Pine shell from unauthorized access. As we noticed that we can connect to our Pine shell in any time and anywhere. Now, we want to protect our Pine shell from unauthorized access, and we will do that by a very simple technique. We will add a secret word to our script, and we will check that if the first string or the first thing that comes from the attacker machine, if that is equals to our secret, that means a secret word, of course, that means that the attacker is authorized and he can start executing command on this system. If that has not happened and the secret word is wrong, I can print a message, I can take any other procedure that I want. But mainly, I will start by declaring a secret, and we'll give a secret word a security for an example. And I will start here by letting the command here, of course, I will receive the command, and I will make a while loop. This while will be here, while if statement. This if statement will make sure that the command equals to the secret, and I will declare this as a string or convert it as a string and strip the line terminator from it to make sure that it will be like this and in this structure. Okay, I will now make sure that if this command is correct, I will send to the client.send hi boss, for example, to make sure that this client is authorized and I told him as a bind shell to start communicate with me. And here while true, I will start receive command here equals, I will just recopy this line, no problem if I just did that or not. Just I will make sure I remove this to, can you guys make the know the difference between them, and I will save the result. Of course, here you can add any else statement that you want. Else you can print anything that you want on your side. You can log it. You can do whatever you want. I just don't want to add an else here. That means the program will not do anything. Okay, I will close that here, and I will close that here. I will, sorry, I got a F, okay, sorry. I will Python example 9.py again, and I will connect to the Pine shell. And as we can see, I connected to the Pine shell without any problem, but I can't execute the command directly. I need to offer or to send, sorry, my secret that I declared declared that here, and I need to send it here, security, and I'll press enter. Oops, I have problem. Oops, I'm sorry, it's a secret actually. It's my fault. Secret, okay. Python, okay, we have to change the port. The connection is closed by incorrect way, sorry. Okay, and 2001, we changed the port number. As we can see up, everything is good. I connected to the bind shell to the on another port. Now I will send security as my special words with S capital security, and I will press enter. And as we can see, I received a high pass because the script is checked for my, or the bind shell script checked that I'm authorized and I have the key and I have the password, which is secret security, to start executing the commands. And now I can execute ID, who am I, uname-a, any command that I want, but I want to add a line terminator here to be more readable, more usable, of course. Python, great. I will send security, and as we can see, high pass, and I'm ready to send my commands without any problem. And we now have a protected bind shell that is totally protected from unauthorized access by adding 1, 2, 3 lines. Actually, 3 lines of code are enough to protect your bind shell from an unauthorized access. Of course, in the coming lectures, we will talk about how we can make an executable files from our Python script, and how we can somehow close the source code or Python source code. That means that we didn't just protect the script from reverse engineering. We didn't we didn't protect the script from reverse engineering. It can you can perform a reverse engineering attacks and know what is the content of this file actually, but or the way that the file is working on. But mainly we just make it an executable, and you can run it without any problem and without any fears that the system admin or any user that could simply read your source code. Hope you guys enjoyed this video, and see you in the next lecture. Hi guys, and welcome. In this video, we will talk about how we can use PyInstaller on Windows to convert the Python script to exe file on Windows platform. We will use a previous Python script, which is the reverse shell Python script. We wrote it before that. And as we can see, this is the code of the Python script that we wrote before, which is a very simple reverse shell script, which is connects back to the attacker on the specific host and port, and then start receiving commands, executing them, and resend them to the attacker machine. I will just get my IP here, and I will see that I forgot which is the uh, network interface I'm working on. Okay, it's 120. This is my IP address. I will let this reverse shell, simple reverse shell, connects back to me, and I will start executing commands on this reverse shell. Okay, I'll just cd desktop and our reverse shell. It's on port 1337. I will set up a listener, netcat listener on 1337. Okay, I will execute that, and as we can see, we got a connection from the host. If I executed who am I there, I can, as we can see, of course, execute a command on the remote machine without any problem, and we can control it via our shell. We don't have a problem with that. We own this system. Now, we want to assume that this system don't have a Python interpreter to run the reverse shell. So we will convert this Python script to executable file, to Windows executable file. We can use that, or we can generate an executable file, exe file on Windows, by using a PyInstaller tool. PyInstaller tool, we can visit it by its own website, which is pyinstaller.org. I forgot to open that. PyInstaller, sorry, pyinstaller.org. We can visit pyinstaller.org, and we can read more about PyInstaller, and we can know exactly how PyInstaller is work. PyInstaller is one of the most important tools that you need to learn how to deal with it if you want to deal with executables or convert Python scripts to an executables on Windows platform. As we can see, we can just execute pep install PyInstaller on Windows to accomplish that. Also, we can use PyInstaller on Linux, and that's what we will learn, and that's what will I show you guys on the next lecture. For now, I will install PyInstaller on Windows 7 machine by entering pep or script, sorry, here. We can find pep on Python 2.7 scripts directory. We can found by pep 2.7 actually. Pep 2.7, we can find pep 2.7 on this directory actually, and we can install a PyInstaller. I'll press enter, and as we can see, the installation is in progress. I will just pause the video for a second. And as we can see, we have installed PyInstaller without any problem. And if I just, there we can see that we have a PyInstaller.exe. Now to make sure that everything is working good, I will stop this scriptor, just will close it and open another PowerShell. And I will just make sure that desktop, we can see this is the reverse shell here. I will just take this full path here and PyInstaller.exe, and I will give that the reverse shell. Then I will enter some options. But before that, I will make sure that the main idea will be clear to you. I will execute the script PyInstaller and waiting for program to finish, and as we can see, the program, our PyInstaller is finished packaging the reverse shell, and we can see that we have two directories built in dest, two new folders built in dest. Our executable will be in dest, and as we can see that there is a reverse shell file. We can enter to it, and we can see that we have multiple files, DLL files and exe files, which is the files that our reverse shell are requiring to or depends on to make sure that everything is working. So we can run the reverse shell. If I run the reverse shell, I have a problem. Seems I already got a connection fused. I will just launch the listener, and I will execute the script. And as we can see here, we have a new command shell. Who am I? There, and everything is good for me. I don't have a problem with that. But as a penetration tester, I need more powerful executable. I have many DLLs files, and I have not structured portable executable or not clean file. I have multiple DLL files and so on. I need to tell PyInstaller to make one package, or packaging the exe, not just converting the exe. I need to packaging the exe into one file, one exe file. I can do that simply by giving the reverse shell or PyInstaller, sorry, the required arguments to make sure that everything is working fine to me. I just want to show you something else. If I enter to scripts, dest, reverse shell, and of course I will just kill that, relaunch the script here, or the listener, sorry. If I I want to view that on large icons. Okay, this is the executable file that I have. If I double click on it, I have this CMD window. I don't need this to appear on the remote system. So, and of course I have my shell working and don't have problem with that. So we can give PyInstaller some arguments, some extra arguments to deal with it. I will just clear this, close this, sorry, and I will clear this terminal and relaunch the listener and delete all these files, delete the dest and the build directories, and I will do the following. I will back to my, sorry, I closed the main PowerShell screen. I will enter that Python scripts here. Yep. Okay. Now we will relaunch the PyInstaller, and we will give the PyInstaller the executable, or the Python script path. Sorry, I don't have it with me here. Okay, I'll give them C, users, Harry, and reverse shell. Oops, right. Okay, no problem. Where's the another PowerShell here? I will just copy this and I will paste it here. And I will, oh, sorry, the desktop, I forget it. Okay, now we will add the arguments that we want, or the options that we want, and I can simply add this by one file. I will use the one file option and the windowed option. The one file option will generate an executable file and back all the DLL files, the libraries, and any dependencies for the program on one file. That will mean I have a portable executable file. The windowed option will make us generate a very simple exe and run it without pop-up, without the CMD pop-up or appears to us. And this is the main usage for the windowed function. Also, we can define or determine an icon. We can select an icon for our reverse shell, we can add the portable executable information to it, and I will attach a detailed article for you guys so you can see more options and use more options for the PyInstaller on Windows platform, and you can explore more and search more about the PyInstaller. Okay, now I will execute this command and waiting for PyInstaller to finish from that. And as we can see, yep, PyInstaller is finished now. And as we can see, if I go to dest, I will see that I have here with a view large icons, I can see that I get an reverse shell with a one portable executable file without any problem. I will make sure that I am listening on the 1337 port, and of course I do, and I will launch the reverse shell. If I back here, I can see that who am I? Oops, I'm sorry. There is problem happened to me, and we don't have sorry, I will read that. So guys, I'm really sorry for that. I just get confused between the reverse shell for Linux or Linux version and the Windows version. We mentioned before that there are two types of reverse shells. We will use them and we will use during this course. I use the Linux version, which is use the sub process, but the Windows version will use the OS library instead of sub process library. I just add the code and recompile it, and I will recompile it again for you to make sure that everything is good for you and everything is clear. For this here, I will from href Windows or dest. Oh, sorry, I just dealing with a PowerShell here, not del, but I will just delete them instead of PowerShell. Okay, clear. I will just, as you can see, reverse shell 2.py, which is the Windows version of my reverse shell, and I will press enter. And as we can see, PowerShell is working on now, and should, yep, generate the dest, and this is my reverse shell. I will just move it to the desktop, and I will just okay, I just launched the launched again the listener. Everything is good. As you can see, I determined the host and the port, and I just used a very simple line here to execute the command. I use os.popen instead of subprocess, because if you read more about that and read more about the way that PyInstaller converts the code, you will see that there is a problem with the subprocess on Windows when we use it with PyInstaller or Py2xe in some cases. So we will use this. We will use os.popen, which is execute the command, and we will send, we will use read, of course, to read the result of executing these commands. Then we will send it to sock.send, and I explained that before. And now we are ready to run the reverse shell 2.py, or sorry, .exe. I'm sorry for that. As you can see, that is .exe, of course. We don't have problem with it. And as we can see, we got a connection from the target, and we can now execute who am I. We can execute dir, and we can use the system. We can use the CMD or to control the system via our reverse shell, Python reverse shell, which we converted it later on to an exe file. And as we can see, everything is working good, and we don't have problem with that. So here, of course, here's the listener, and we don't have a problem at all using it. So hope you guys enjoy this video, and see you in the next lecture. Hi guys, how we convert a Python script to an ELF file or a Linux binary. We will use PyInstaller as we used before on Windows platform. We will use on Linux platform to convert a Python script to an executable file. We will use this script, reverse shell.py, which we programmed in previous lectures. You can see the source code of this program, which is a very simple reverse shell, which is connect back to the attacker and start receiving order from the attacker and execute them on the targeted machine. Now, if I just test this script and I listen to port 1337, which is the port that this script connects to, I can see that I get a connection and I can start executing commands without any problem. I can start executing ID, I can executing uname-a or uname, who am I, whatever the command that I want to execute on the targeted system, I can use that. Now, if I want to, let's say, convert this script and use this script as an executable file, simply I can use PyInstaller to do that. You can read about the ELF file or the executable and linkable format from Wikipedia, and you can read more about PyInstaller from the official website, pyinstaller.org, and read more about the features. And we talked about PyInstaller on the previous lecture. So we'll start using PyInstaller to do that. The operation is very simple. I will just clear that and I will close the script. And I will start by PyInstaller. By using PyInstaller, sorry, we will use pip. Install PyInstaller to install PyInstaller on Windows or on Linux machine, sorry, as we did on Windows machine. And we will press enter. I already installed PyInstaller on my machine, so you will see that all requirements already satisfied. So now we are ready to use PyInstaller without any problem. Okay, now we will start PyInstaller and we will give the PyInstaller the Python script that we want to convert. And I will just take the name, which is reverse shell, and PyInstaller reverse shell.py. And I will press enter. Now, PyInstaller are packaging and generating the ELF file without any problem. But we just still have a little problem here. As we can see that PyInstaller finished generating the ELF file, and we can see the file by visiting dest. As we can see, this is a reverse shell here, and we can see that we have a reverse shell executable, but we have a lot of libraries or executables that the reverse shell depends on. We can simply solve this problem by using one file argument to package all the libraries and all the dependencies of the reverse shell executable into one file. And we can do this in a very simple way. We just remove the dest, and we will remove the belt also, and we will write the space. Okay, /rf reverse dot spc, and we will execute the PyInstaller reverse shell, and we will give it one file to package all the dependencies and libraries and so on in one executable file, on one ELF file. And we will press enter. And as we can see, PyInstaller is working and already finished the packaging and generating operation. We will now enter the dest, and we can see that, yep, we have one file, one executable file, which is reverse shell. And if we used file command and we pass the reverse shell to it, we will see that, yep, we have an ELF file, and we don't have any problem now to use this reverse shell executable file. If we want to execute the script, for that, just let me set up the listener on port 1337. Now we will execute the reverse shell, and we will press enter. And yep, as we can see, we get another shell and we get another reverse connection from the ELF file. And we can execute who am I, we can execute ID, uname-a, and we can execute any command that we want. Now, this executable file, we can use it on any Linux distribution that we want, and we can use it without any problem. And you can test that, guys, and let me if you have any problem with the executable file. So, hope you guys enjoyed this video and see you in the next lecture. Hi guys and welcome. In this video, we will talk about how we can convert a Python script to an exe file on Windows platform. Later on, we talked about how we can use PyInstaller to achieve that. But in this video, we will talk about how we can use Py2exe to accomplish that. You can read more about Py2exe and read more about the theory and the mechanism that Py2exe use to convert the Python scripts into executable Windows programs or executable files. I will show you how to set up a configuration file that you can use it with Py2exe to convert Python script to an exe file and working without any problem. First of all, you need to download Py2exe. You need to download the version with your Python 2.0 version. I will use it with Python 2.7 as I mentioned before. You can click it and click the link and wait for the pop-up, tell you that you're ready to install the file, and then you can install it without any problem. I already downloaded it, and you can see that in here. You can just double click on it, next, 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 and of course all things will be good after that. You're now ready to use Py2exe. If we use PowerShell here, if I go to cd Python 2.7, I go to scripts. In the previous video, I show you guys how we can use PyInstaller, but Py2exe don't have an exe file or an independent exe file that you can use it. So you need to use a configuration file and deal with Py2exe as in a library. Of course, here is our reverse shell code, and this is the convert.py code, which is the configuration file or the setup file for my Py2exe script. As we can see, we import setup method from destutils.core. Then we use or we import the Py2exe directly. Destutils from destutils.core. Again, we import the setup method, then we import Py2exe, then we call the setup method with multiple arguments. The first argument will be options that we will use Py2exe, or Py2exe has also options such as bundle files. This option, like the one file in PyInstaller, compressed to make sure that everything is compressed and we don't have another libraries and so on. Zip file none to not generate libraries with a zip extension or zip file. Here Windows, I will just get it back to console actually to show you guys what is the difference between console and Windows, and of course the alternative with PyInstaller, the alternative options of course. So now we are ready to execute the convert.py. We will convert.py and we will Py2exe pass the Py2exe argument to make sure that the convert.py will convert the reverse shell.py, which is the file that we want to convert, and we will press enter. And as we can see here, we have dest and build. Dest, we can enter to dest. Sorry, okay, we have two files. We can just delete w9xp open. We don't have problem with it. And we can run the reverse shell. I will make sure that I set up the listener already. Now I will just execute the reverse shell, and as we can see, I got my command shell. Who am I? Sorry, this is an Arabic. Who am I? I don't have any problem to accomplish that, of course. So this is my shell, but I still have one problem. And this problem is this CMD screen. If I just close it, I can see that I cut the execution of the program, and I will reset up the Netcat to listen. And I will just make a very simple change to my convert.py. The console option, make sure that this program is running with the CMD open console. So I will change this to Windows, sorry. To make sure, Windows, to make sure that I will run the script at the background without any console appears to me or to the user, of course. Let's see. And we will convert it by py2exe again to make sure that, yep, we don't have any problem with that. Now we will enter to dest. We can get the reverse shell. We can edit the icon, and you can read more about how we can change the portable executable icon or use py2exe to perform more options on that. So this is the Netcat listener. We don't have problem with it. And we can just launch the reverse shell to see that we have a connection from the target. Who am I? We didn't have a problem with it. There, and we can execute any command that we need on the remote system. So I hope you guys enjoyed this video, and see you in the next lecture. Okay guys, in this video I will show you how we bypassed some antiviruses using our Python reverse shell. As we know, if we used reverse shell for one of the most popular penetration testing frameworks, such as Metasploit, if we generated one from MSF Venom, and we will use this reverse shell or this payload to attack a remote machine, we will have a problem with that, because this reverse shell for Metasploit will be exposed and will be defined as a malware from the antiviruses. So we will scan the three main reverse shell that we created. We created actually two reverse shells before. We created one using py2exe and the second one using PyInstaller, and we show you how we can use them to attack systems and how we can control the systems using the reverse shells that we created. Now we will compare between them using virustotal.com website, and we will scan each one and see the result and what is the best one that you have to use during any penetration testing attack. So we will upload. The first one will be where is the shells, will be the Metasploit one. Then we will upload the py2exe one, and we will finally upload the PyInstaller version of the reverse shell. And as we can see, uploading finished, computing hash. So I will just pause the recording until it will finish. Okay guys, we finished scanning all the files actually, and we can see that the Metasploit reverse shell actually is detected from 48 from 64 antiviruses, and we can see them. But I want to make sure that you guys realize that this is a scan time scan, not a runtime. In the runtime, it will be different. But in scan time, yeah, we get the right results for a scan time scan. As we can see, this is the Metasploit um, um, reverse shell scan result, and this is the Py2xe, which is detected from 2 from 63, just 2 from antiviruses detect our reverse shell, which is semantic and essential one. I think I haven't heard before about this antivirus setting engine. Okay, machine learning module. It's just detected from 2 from 63 antiviruses. Actually, this is a great result for a reverse shell. For the PyInstaller one, we can see that it's detected by 15 from 64 antiviruses also, and we can see it's not good result to be detected in this way for a scan time. It's not good enough, but it's good. It's not actually something you can depend on, but we can see it's better than the Metasploit one. It's better. And you can see also the Py2xe is the best, actually is the best reverse shell that we programmed. Even it was used the same reverse shell code as you noticed and as we saw before. So if you want to test, I can just test that a quick way. This is the Metasploit one. And of course I set up, here, I set up a Netcat listener before, and we can see, yep, we get a shell, who am I, we get the result. I will exit it, that will clear Netcat again. I will run the Py2xe shell. As we can see, who am I, anything that we send is already get executed, and the result will get back to us without any problem. And I will just close this, Netcat again. Now we'll reverse shell by installer. Sorry, I have to yes here. Okay, and we can see that who am I? I have a good result here, but I want to tell you guys that there is a difference between these three files. Actually, the Metasploit one got 72 kilobytes, and it's the smaller size between them. The reverse shell got approximately 5 megas. Reverse shell with a PyInstaller get approximately 4 gigabyte, and we can see that the Metasploit one is the smaller one, or the smaller one between them, and the Py2xe is got the average one, and the largest file was the the Py2xe got the largest file, and the PyInstaller got the average size of them. So you can compare more features for them later on, but mainly I want to show you guys what is the results between them, and what is the results and the difference between them, of course. And I hope you guys to look more about them and to can write more codes and different techniques to bypass the antiviruses. So hope you guys enjoyed this video, and see you in the next lecture. Hi guys, and welcome. In this video, we will talk about how we can execute a command without being logged in Linux operating system. We will run and program a very simple Python script to execute that. We will now can run any command we want without being saved in Linux operating system. As we know, for we just open a new terminal here. If I executed any command such as uname-a for an example, this command will be stored in Linux operating system, and we can see that this command is stored and we executed it already by executing history command. History command will show us all the commands that are being executed on Asker user and on any user, of course, that you are logged into. If I just executed this command, I will see the last command that I executed and every single command that I executed in the system. And as we can see, the last command that I executed is uname-a. Then I executed the history command. So during any penetration testing operation, we need to hide these commands, and we don't need anyone to know what is the commands that we are executing or executed in the remote system. So we will program a very simple Python script to do that. We will start coding, and we'll start by Python interpreter, of course. Then we will import the OS library, which we talked about it on the previous lectures. Now we will give a command. We will declare a command variable, and we will use row input. And we will save shell, for example, save shell at host, for an example. Then we will give it like that. Then simply we will execute this command by calling os.system, and command. Okay, now while true, so we will guarantee that the script will run for infinite way, or infinite loop, Okay, now this script is ready to execute our commands without store it, because we will use os.system function to execute the commands on the system without being logged, because we are already execute the system using this function, not the bash directly, or not the terminal, directly. Okay, I will copy this code, and I will save it in my other machine, which is a Kali machine. I already logged in using SSH, and I will nano it as a save shell.py. And I will paste it. Then I will execute a bunch of codes like command 3, command 4, command 4, command 5. I can execute it as any command, or any command that I want on the remote system. For example, I will execute cat etic pass wd and clear, for an example. And now I will run my script. Before that, I will run the history command to show you guys that I can see all the commands that I executed in the system. I will use history. And as we can see, I executed command 3, command 4, command 5, of course, nano save shell, and cat etic pass wd, clear, and history. Now we will run the save shell.py, and we can execute the commands now without being logged on a Linux operating system. I can execute id, I can execute uname-a, I can execute any command that I want. I can execute now, for example, pwd. I execute maybe cat etic pass wd again, and I can execute a clear too. Okay, now we can just exit this Python script, which is the save shell, and we type history command. As I can see, I can't see my command that I executed already in a save shell. So in this way, I programmed a very simple Python script that executing commands on any Linux operating system without being logged, or without logging my commands that I executing in this machine. So, hope you guys enjoyed this video, and see you in the next lecture. Hi guys, and welcome. In this video, we will talk about how we can create a rainbow table and how we can deal with hashes in Python. We will learn how to use hashlib and deal with hash functions using Python to build rainbow tables to deal with hashes in different ways. So I will start by launch the Python interpreter and start dealing with hashlib library. Hashlib library is one of the most useful libraries to deal with hashes in Python. As we can see, if we type hash, dir hashlib, sorry, we can see that there are more than one function that we can use. If we just use hashlib dot algorithms available, we can see that we have a lot of uh, functions that we can use on or using by using hashlib in Python. Also, we can set the algorithms here to see that what is the algorithms that we can or we will use in this video. I will show you how we can use with MD5 hashes and SHA hashes. We will deal with multiple techniques to use actually the hash that we want to generate rainbow table or to generate a hash or to calculate a checksum, whatever you want, you can deal with hashlib to accomplish that. Okay, we will start by building a very simple function that takes an argument, which is the string that you want to calculate the hash for, and then you can just print out this result. We will, before actually I will start, I will show you how we can deal with MD5 hash for an example. I will use hashlib.md5. Then we will pass the argument that we want. For example, I want to calculate the hash for Askar or any other word that you want, but I will use Askar for that. And I will use hex digest to print out the result in hex without any problem. And I will press enter. As you can see, guys, I calculated the hash, and the hash printed out to me the value that this string equals to this hash. So Oscar equals to this hash, and I'm sorry for that. Oscar, let's say MD5 equals to this value. Also, I can use SHA1 for an example. I can SHA1 Oscar, and I can see also this is the result for SHA1 for Oscar word, and you can do that for any other string that you want. You can just see that I can Udemy, I can accomplish for iSecurity for an example. I can use it for let's say security. I can use it with any word or string that I want. So if I want to build a rainbow table using this hashes, I need to write functions to call during the rainbow table generating, and I will talk more about the rainbow table later on. But I will write a very simple function to take just a string instead of writing this line. I will just make MD5 function, and I will pass a string to it. I will just, it's a variable name string, it's not a variable type. Then we will write this line md5.hex and we will pass the string. Of course, we will return the value. Okay, now if I just call MD5 with the value Askar, I can see that, yep, I get the same result from writing this whole line, and I can see F or MD5 equals Askar equal Askar MD5. I can see, yep, this is a true statement, and this value actually equals this value, and you can just perform that for all the hashes. If you just You need to take ISEC or security, for example, to 512 SHA. Of course, we can get this hash for SHA 512. We don't have a problem. We'd accomplish that with any other hash that is supported by hashlib. So in this way, we can deal with hashes using hashlib library, and you can, for example, enter any string to be calculated using your function like this, or write your own function to calculate the hash for SHA1, for an example, by just replacing the method that existed in hashlib to make sure that everything will be performed in a perfect way. So now we will start writing the code to let's say write the simple statement, a very simple statement to check that if the string, like let's ask for an example, equals to an MD5 asker for like this. So we will just take the asker and save the value of asker in a variable and start generating. Sorry, here just name equals asker, and we will pass the name to our function to calculate again the hash to see the multi-purposes that we will need during this course. For now, I will get enough from that and see you in the next lecture. Okay, guys, in a previous lecture, we talked about how we can deal with hashes in Python and how we can create hashes in Python. So, in this lecture, we will talk about how we can create a rainbow table with a very simple technique that we will read from a dictionary or a list file, and we will start generating the rainbow table based on the words on this file. I just, for example, of course, build a very, very, very small list that contains several words to read from these words and generate the rainbow table. But in real world, you need to have a very big word list if you want to create a functional or a very good rainbow table. But I will use these words, just these words, for testing purposes and to make sure that you get the main idea from the rainbow table generation. Okay, so we have a list of text here. Now we will start by determine the Python interpreter. Then we will import sys and hashlib. Okay, now we'll check if len sys.argv not equals to 2. We need actually the file name. No, we will just need 1. We will print here. We'll print an error to the user, which is Python, for example, rainbow table.py list.txt, for example. Okay, then of course sys.exit. Okay, great. Now we will start reading from this rainbow table, and I will start a file handling f equal open, for example. Then I will open the or file name equals sys.argv1. I will open the file name. Then I will open it in read mode, of course. Then the data or file data equals f.read lines. Okay, now I read each line. I don't have problem with that. Therefore, check that for line in file data print line. I'm sorry. Okay. Python rainbow table list of text. Oops, we have problem. Rainbow table not equal to okay, I'm sorry, it's 2. Actually the Python rainbow table, the file is the text. Okay, great. But we have a problem here, which is the line terminator. We need to strip the line terminator here. Okay, good. That's very good. So we can we can now handle the file and start generating the hash. So I can deal with the hash by hash equal hash let's say hash word, for example. We will use hashlib.sha. We will create an sha rainbow table, for example. The line.strip, then .x biggest, as we talked before. Then we will just print the word and the hash. Format. We will say here I have the line. .strip for can just declare it here, but I don't want to. I just want to get the main idea from stripping the \n. Okay, now hash word, and if I just type Python. Now, before I run the program, I want to make sure that you are guys getting the main idea. The main idea is very simple. First of all, I get the file name. Then I open the file name using read mode, of course. Then I make a read lines from this file. Then I read each line separated. Then I make a strip to each line to make sure that I will read it without the line terminator, of course. Then I get the SHA hash for this word, which is in line here. Then I print the output without any problem. So I will make Python here. And as we can see, we get a very simple result for a very simple words here. Actually, we can make a demo for for a huge word list and start typing the rainbow table here. And of course, we can save it to rainbow.txt. And now if we want to search for hash security, for an example, we can make cat rainbow.txt grep security, and yep, we can get the SHA1 hash for it. And this way we can generate a very simple hash or rainbow table that contains the name and the hash without any problem. And in the same way, you can do it for a very large list or dictionary file. You can simply use this code to generate the rainbow table without any problem. You can just run it and get back to it in any time. So if you want to actually generate a rainbow table for a huge dictionary, actually it's gonna take a lot of time to accomplish that. So hope you guys enjoyed this video and see you in the next lecture. Okay guys, in the previous lecture we talked about how we can save the rainbow table result into a file using a terminal, as we can see. But in this video I will show you how we can do that using Python without getting the shell involved into this operation. So we will need output variable. We need to open another file. We will open, let's say, rainbow table, for example, the text, and we will open it with write mode, of course, to write into this file. Here we need to make output, or first of that, we need to data equal. Then we need to f.write. We will write the data and the line terminator for each word and hash, of course. Then we need f.close and we are done. So we opened another file named rainbow table.txt, which is the result file. Then we declared a data which contains the line, which is the word, and the result of hashing the hashed word. Then we saved it into the file, or write it into the file. Then we add a line terminator for each result. So we will get the name, the hash, line terminator. Okay, let's give that, let's start this and start, less the text here, and press enter. Oops, we get not open for writing. Yeah, oh, sorry, it's output here, output.write. Okay, we are ready now. If I press enter, yep, we get it. Now we saved it into rainbow table of text, nano rainbow table of text. And as we can see, we get each word with the hashed word. So if I try to get the security hash, I will make grep security, and I press enter, I get the SHA hash for this word without any problem, of course. Now you can start testing the script for a huge dictionary and get back the result to me, and I will make sure that if you have any question, I will be there to help you guys. So hope you enjoyed this video, and see you in the next lecture. Hi guys, and welcome. In this video, we will talk about how we can program a very Python script to check for the MD5 or whatever it was, the hash type for the file. This operation is very, very important if we want to make sure that the integrity is good, and we want to check the integrity on our files. We can use an MD5 sum or SHA1 sum on Linux to check and calculate the hash for a file. But we want to learn how we can write a very simple Python script to generate or to check or to calculate whatever it was, the operation that you can call it for a file. So we will check the MD5, or we calculate the MD5 for a file. Okay, we will start by, of course, using the user Python, the interpreter path. Then we will import sys and hashlib. We will take an argument, just one argument from the sys library, which is the file name. So we will check if len sys.argv not equals to 2, print python check sum.py file name. Okay, name. Great. Here we'll just sys.exit. Okay, everything is good. Now we will start taking the arguments from the user, which is the file name, will be the sys.argv1, which is the argument number 1 from this or from the user. Then we will create a simple function called MD5 that will take a string, which is the file contains, to calculate the file contents and generate the MD5 hash. We will just return the hashlib.md5, and we talked about that in a previous lecture, hex digest, to show it as a hex for us, or hex digest, of course. Now we will declare a file, open file name with a read binary to read it and pass it later on the MD5 function that we created. Then fi.write, or read, that will be declared in a data variable. Then we will calculate it using final hash. We'll declare final hash equals MD5 for the data. Now we calculated it and we don't have problem with that at all. Now we will print the file and the hash for the user. Format, file name, and final hash. Okay. This is a very simple script, again, that takes a file name from the user and store it in a file name variable. We declared an MD5 function. This function or method taken a string as parameter. Then we return the calculation of the MD5 for this string, and we of course take it as a hex text. So then we fi equal open. We open the file that we want to read, which is of course the user give us the path for this file. Then we read it and calculate the MD5 hash for this script. Then we print the final hash. I want to make a very simple addition here. I will see MD5 to calculate not just the MD5 hash. I want this script to calculate multiple hashes. So we will just here final MD5 hash here. That will declare another one for SHA1, and here I will replace it with SHA1. I will copy this line, SHA1, file name, final SHA1, and here of course final the MD5 hash. I'll take this as final SHA1, sorry, final SHA1 hash SHA1. Okay, now we just add another function that calculate the SHA1 hash for the string, the given string, and the given string here will be the data of this file. And we talked about how we can use the SHA and MD5 one later on, and you can check the previous lecture to make sure that everything is good with you. Then we open a file. We just calculate the MD5 hash for the file content and the SHA1 for the file content, of course, for the SHA also. And we store them in a final MD5 hash variable, final SHA1 hash variable. Then we print them to the user. Okay, just I want to sure that everything is good. Okay, we are ready to perform that. I will create a file called file, for example, file c dot text, and I will put my name as Muhammad, and for example 1 2 3 etc. I don't have problem what is the data was. I don't have problem with that. Now I will make a checksum SHA1 sum for file C. I can get the file hash, and this is the file hash, of course. Then I will calculate the MD5 sum file C, and I get the MD5 hash of that. Now our script should give us the same result that the SHA1 sum returns to us, and of course the MD5 sum returns to us. Okay, I will just Python. Sorry, not safe shell. Safe shell we programmed in another lecture. So we what is the file name? Okay, checksum here, and I will give it file C. I want to make sure that if I press enter, it will print out this help banner for me. If I just pass the file C and press enter, as we can see, yep, we get the exact calculation. We can get exact value that MD5 is this value, which is right, and SHA1 contains this value, of course, and you can add multiple hashes, SHA 512 or whatever you want. You can just add it without any problem. So I hope you guys really enjoyed this video, and see you in the next lecture. Hi guys, and welcome. In this video, we will talk about how we can program a secured reverse shell. We will program a very simple reverse shell as we used to do, and we will secure this shell with SSL. Actually, we will secure the connection for this shell using SSL, which means that the connection between the target and the attacker will be encrypted. So we will start by determine the interpreter path. Then we will import OS, Socket, and SSL library. We will use SSL library to create a Socket wrapper, and we will wrap the Socket for the connection. We don't have a problem with that. We can use it using a very simple SSL wrapper to wrap the Socket. As I mentioned before, we will use the SSL library, and we will start by initialize the Socket as we used to do. Socket.socket, socket.af underscore inet. Oops, what is that? af underscore inet. Yep, then socket.sock stream. Now we will not use the socket directly. We need to wrap the socket before. So we need to create wsocket for example, and we will use the ssl.wrap underscore socket. Then we will pass the sock to it. Then we will pass the SSL underscore version, and we will equal that to SSL.protocol TLS v1. Okay, SSL.protocol underscore TLS v1 to choose TLS v1 as the main technique or SSL version, sorry, that we need to do. And absolutely, there is many parameters that you can read more about it and you can use it. But in this technique, we will use this parameters, and absolutely, if you want more advanced thing, you can read more about the wrap socket function and how you can use it later on. So now we just let's say created another socket, but this time it's an encrypted socket with SSL. Now we can continue as we learned before. We can start with wsocket.connect. We will connect to host and port, and we will declare the host and the port here. The host will be the local host, and the ports will be 8888, for example. Okay, now we will go to while true. As we learned, we will start declaring command wsocket.receive, and we'll receive like this. Then we will make result equal os.popen. Then we will receive and pass the command, execute the command, read the command, and save the result into result variable. Then we will send, wsocket.send. We will send the result of execution, this command, which is the command we will receive from the attacker. Okay, I will quit this. I'll open another one, and I will go to opt course examples, and here I will make sure that I will use ncat for that. Ncat, we talked about it in the previous lectures. Actually, we will use SSL. We will use ncat --SSL to make sure that it's an encrypted connection, and we are using SSL for that. Then we will use the -VLP to determine that we are using the port 8888. The listener are working good. We don't have any problem with that. Great. Now we will launch the secure.py. And as we can see, we get a connection. We don't have a problem with that. And if I type ID, for example, I get the result. Who am I? Uname, uname-a. I don't have any problem with that. Okay, I will try now with without actually the --SSL, and I send the encrypted data. Sorry. As we can see, yep, we did the connection, but I can't understand anything. As we can see that we get a massive exception here because there is no handshake actually with the SSL, and I can't deal with the connection. If I get that again, as we can see here, if I get the connection, I get a rubbish data. If I try to send any command, I will get something is accepted here. As we can see, we got a handshake error. We have um, uh, a error with the connection with the Netcat here. We don't use SSL, and my script use SSL, so we got an error here. So I have to explain that to you for last time. We create a socket. We pass the socket into an SSL.wrap socket to make a wrapped socket, which is wrapped with SSL, of course. Then we use the wrapped socket, which is the new socket, to make the connection and to start receiving and sending the command through it. And of course, we saw how we can execute that using ncat with SSL option. So, hope you are guys enjoyed this video, and see you in the next lecture. Hi guys, and welcome to Mastering Ethical Hacking using Python course. Today, we will talk about buffer overflow vulnerabilities. In this section, we will talk about how we can detect buffer overflow vulnerabilities and how we can exploit it and how we can write the final exploit using Python programming language, of course. I want to make sure that you have a pre-knowledge on buffer overflow, and I want to notice you that I will talk about the very basics thing about buffer overflow, and I will talk about stack buffer overflow in this section. I will not going deeply on any advanced detail in buffer overflow. Actually, I will just explain the main and the basics thing only on buffer overflow. So, hope you guys enjoy this section, and let's get started. What is the buffer overflow? As we can see that the buffer overflow is a security vulnerability that affects applications when you try to store more data in a buffer. And we mean by the buffer here that the buffer is a temporary data storage area. It's like a memory. Let's just say it's like a memory. Okay? And when we try to put more data in this memory, more than it was intended to hold, of course, we will have a buffer overflow and we will have a memory corruption on this program. I will not show you the codes that, or the functions and example codes for vulnerable programs that could cause a buffer overflow in this course. We will not review any source code, but I will attach a very, very important article about buffer overflow and the resources about the buffer overflow. So you can read it and make sure that you will prevent the buffer overflow from being existed in your code. So again, if we just take an example, if you have a memory and this memory you allocated a memory and this memory should hold just 20 bytes, just 20 bytes. And you try to put more than 20 bytes. Let's say you put a 100 byte in this memory. In this case, you will corrupt the memory and you will cause a memory corruption, and that's like, of course, a buffer overflow. And when you try to handle more bytes than it was intended to hold for a predefined memory, you will get a big problem here, and this problem called buffer overflow simply. Now, we will try to exploit this buffer overflow vulnerability and, of course, this flow to make sure that we will inject our code into the memory. And our code here refers to shellcode, and we will talk about shellcode deeply later on. Okay, as we can see, this is a very simple memory that contains the arguments, saved EIP, the return address, and I assume, guys, you have a very simple knowledge about assembly and about the registries and how it's work. I will, let's say, explain that in general another lecture or the next lecture, of course. I will talk about this basic things, but I will not go deeply on it. So it's better to you guys that you have a pre-knowledge on assembly and in registry, how you can use a debugger, and I will show you a very general things in the next lectures. So if we have a very simple memory here, as we mentioned before, that has the top of the stack, saved EPP registry, saved EIP, which is the return address, and of course the arguments. We will try to enter more data than is usual, and we will try to change the structure for this memory so we can cause a crash. Then we will locate how many bytes that we need to cause this crash. Then we will need to control the EIP, which is the next instruction pointer, and make it, as we can see here, refers or points to the shellcode, which will be in the stack mainly. And as we can see here, to exploit the buffer overflow, we need to control the EIP, hijack the EIP, and make a jump or call ESP. And of course, there are many techniques to do that, but in this section, we'll talk about how we can exploit the stack buffer overflow using jump or call ESP instructions. Then we will make the EIP points to the shellcode, and once we do that, we will get a shellcode executed in our memory or in our program, which is on the remote system that we are trying to exploit this vulnerability on it. Basically, the shellcode is a very simple set of instructions that helps us to execute something on the remote host. The shellcode could be a reverse shell. The shellcode also could be a bind shell, as we talked about them in a previous section. Also, the shellcode could be a command to be executed on the system. We'll talk more about the shellcode and how we can use Metasploit, MSF Venom to be more specific, to generate shellcodes and how we can deal with them later. So we need mainly three components to get a working exploit. We need to determine the crash bytes and how the bytes that we need to make the crash. Then we need to hijack the EIP, and of course we can do that by get a jump or call ESP. As I mentioned, there is another techniques, but in this section we'll talk about how we can get a jump or call ESP to make sure that we will point again to the top of the stack here, which we will put the shellcode, our shellcode. Then we need a shellcode to put it here. So we need three main components again. We have to determine the crash bytes. Then we need to hijack the EIP. Then once we hijack the EIP, we will put the shellcode to make sure that the EIP will point to the top of the stack, which is the ESP registry controlled by ESP registry, and we will make sure that the EIP will point to the top of the stack. So basically, again, this is the stack, and we have determined the bytes that we need to cause the damage or the crash on the memory. We hijack the EIP, and we simply made the EIP points again to the shellcode. Once we get that, we will get the shellcode executed on the memory, which of course led and successfully exploitation for buffer overflow. So it's very simple to do that, and I will show you guys how we can do that. But I hope from you to read more about buffer overflow, to see more resources about buffer overflow, and I hope to practice more and more on the basics of buffer overflow, and I will show you, of course, how we can do that during this section. So hope you guys enjoyed this video, and see you in the next lecture. Hi guys, and welcome. In this video, we will talk about Immunity Debugger. Immunity Debugger is one of the most brilliant debuggers that you can use. Immunity Debugger, we will use this program or this debugger during buffer overflow exploitation progress, and you can use it in any reverse engineering progress that you want to also. You can install Immunity Debugger by visiting immunityinc.com. Then you go to download section. You can Click here and fill out your information, then press download. I installed Immunity Debugger and downloaded it actually and installed it. And as we can see, this is the icon of Immunity Debugger. If we press the Immunity Debugger, we can see that we have 4 main screens. The screen here on the left, we have the deassembler or the assembly code of the program. Here we have the registers. Here we have the stack to see what actually goes on in the stack. And here we have a hex dump for the data on the program, actually the program hex dump. So if we just take a look at one of the program here, if we try to open one, and we open the violin.exe, actually we have a very simple view about the assembly code here, the registers, we have EIP, we talked about it later on the previous, in the previous lecture, and we'll talk about it later on. We have the stack. We have what actually goes on the stack here. You have the top of the stack, and you can see what actually goes on the stack without any problem. And as we can see here, the stack actually is points to this address, which is this address here. Of course, we talked about the stack and the top of the stack on the previous lecture. We have the registries: EIP, EDI, ECI, EPP, and so on. I prefer to read more about them to know what actually what actually this registry is doing, and what is the main purpose for each registry. Here we have the assembly code, as I mentioned. Here is the stack, and here is the hex dump for the program. We have a lot of tools that we can use. We can see here, if we go to debug, we can see the animate into, animate over, which means step into, step over. Actually, we have also the prick points, the hardware prick point. Here we can see the plugins, the options, the windows that you can use during your analysis for the portable executable, actually. And here we can see the view, what we actually view here. We can view the executable modules, and we can see that the executable modules that the violin.exe depends on. We can see the system DLLs, and we can see the exe by itself, actually. If we press it, we will get back to this screen, and actually you can learn more and more about Immunity Debugger by practicing and reading a lot of useful articles that I will attach to you, and you can find it, of course, in the resources for this lecture. So basically, that's what we need from Immunity Debugger, and that is the only thing that you need to know for now. In the next lecture, we will talk about how we can trace the stack, and how we can see the code, and how we can play with the registries, actually. All of that, we will learn it in the next lectures. So be prepared for that and read more about the registries, the assembly, or the assembler here, the assembly language, and be prepared for the next lectures. So I hope you guys enjoyed this video. See you in the next lecture. Hi guys, and welcome. In this video, we will talk about fuzzing. We will talk about how we can perform a fuzzing, and we will absolutely define the fuzzing. First of all, the fuzzing is an operation when you try to input an invalid or unexpected or a random data to an program. For example, you have to input this data to a program to test how this program will handle this data. So we will learn in the few next lectures how you can program your own fuzzers using Python, then how you can use these fuzzers to know more about the crash, and how you can develop this crash to complete the exploitation of the buffer overflow. So I have a violin.c code, a very basic program written in C that takes an argument from the user and using string copy, take this or copy this argument or this value and copy it again to the dest, which is a character with a 50 byte. Then okay, we will print a string copy to dest and return 0, of course. So what we need to do here, we need to do a very simple thing that is we will run this exe file, which is here, violin.exe. Then we will try to input a data. For example, my name is Mohammed Oscar, like this. As we can see, we take it without any problem. And the program copied the argument for us without any problem. So if we try to add more data, such as my name is Mohammed Askar, and I work as an ethical hacker, I will press enter, and oops, as we can see, we got a problem here. We got an unexpected problem because we tried to input more than 50 byte to this dest. Actually, I take the argument without checking the argument size or the value of argument size, sorry, before I copy it back to the dest. And this code caused a vulnerability called buffer overflow, and we talked about buffer overflow in a previous lecture, and we still talking about the buffer overflow. So you have to check if the argument is in the same size or smaller than dest, then okay, you can copy the data. If it wasn't, you shouldn't copy this data, because if you try to copy it and pass it to the string copy, you will get an error. And this error is a buffer overflow error, and you will get a vulnerability in your code. So mainly we will need to know how we can input a data to the program. And in the next lecture, we will talk about how we can input it using a file and how we can read about how we can look at the registries, how we can look at the stack, and how we can follow the bytes that we entered and how we can handle it to get a fully functional crash. So, hope you guys enjoyed this video and see you in the next lecture. Hi guys and welcome. In this video, we will talk about how we can program a file fuzzer. We talked about fuzzing concept in a previous lecture, and today we will talk about how we can program a very simple Python fuzzer to generate a number of bytes and put them on a file with a customized extension, of course. We will test the local buffer overflow vulnerability, and we will test it on a VU player application. As we can see, this is the VU player program. We will test the PLS, which is the playlist, as we can see here, playlists, VPL, M3U, PLS. We will test the PLS extension. This application is already vulnerable with the buffer overflow, and I will mention the exploit DB link for this application, so you can read the exploit and of course download the vulnerable application and make your tests on it. So let's get started. We'll just start by determining the user pin Python. Then we will import sys library to take the arguments from the user. Then we will check if the len of sys.argv smaller or equal to. We'll just take two arguments from the user. The first argument will be the buffer size, and the second argument will be the file name. So we will print, for example, Python file fuzzer.py buffer size, and the second argument will be file name. Sorry, file name. Okay, then recess.exit. Everything is good. Okay, now we will start declaring variables, and the first variable will be the buffer size, and we will take it as sys.argv1, which is the argument number 1. Now the buffer size will be the number of bytes that the user wants to add to file. So we will just take it as an integer because it's a number, of course. Then we will take a file name, or we declare a file name variable, which will contains the sys.argv number 2. Great. Now the buffer data will be a with the buffer size. The a now we will just add into the file a number of a's with a buffer size, of course, number. Now the a will be very useful when we track the buffer size, or the crash size, or the number of bytes that cause the crash size. It's about tracing the real number of bytes that is required to smack the stack. Okay, we will talk about this later on in more details, of course. Then we will just declare a file, open. We will open a file name. We will open it in writing mode, write mode. Then we will write into this file the buffer data. Then we will close this file. Finally, we will print for the user success, for example, file, we'll get a file name here, generated, sorry, with bytes, and we will just make a very simple format string here. The first argument will be file name, the second will be the buffer size. Okay, everything is good. We are ready to execute the program. Now we will Python file fuzzer.py. If I press enter, as we can see, the script will check. There is no argument from the user, so the script will print this out for us. Great. Now we will just determine the buffer size, which is, for example, 5,000. Then we will save it into, say, list1.pls. Great. I'll press enter, and as we can see, yep, the file list1.pls generated. Let's check. We got list1.pls generated. If we just check it with size, say kilobytes, and list1.py, we can see, yep, 5 kilobytes are already generated without any problem. If we just want to see it with bytes, sorry. Oops, sorry, block size. Forgot how we can just check the block size with a byte. I think it's byte. Oops. Sorry. Just like this. I'm sorry. Okay. We can see that I already checked it with bytes, and I check it with kilobyte, and everything is good. We created the file. Now we want just copy this fuzzer and rerun it into our Windows 7 machine here. It's very simple to do that, actually. I just need to copy this and go here to, for example, Notepad++, and I will fuzzer.py, save it into fuzzer.py. Everything is good. CMD. Desktop, and we will execute it, fuzzer.py, and as we can see, it's required to enter an argument. We'll enter first argument will be 5,000. The second argument will be list.pls, and I will now press enter. As we can see, list1.pls .pls generated without any problems. Now we will close the view player and open it with the immunity debugger, and we talked about Unity Debugger in a previous lecture, and I assume that also you have knowledge about Immunity and how you can use Immunity Debugger. Okay, everything is good. Now we will open a playlist. And to continue the workflow or the execution flow, we'll just press Shift and F9. Everything is good. Now we will just open list.pls, and now we will press Enter. And as we can see, everything is good. We just smacked the stack, and maybe every single thing in the screen contains the A character, which we are generated already from the fuzzer.py. And if I just open the list.pls, we can see that we have 5,000 A character, and we don't have problem with that. When we open that with the view player, we just have a big exception actually, and this exception is very good for us because we are see that the next instruction pointer not controlled but full of with the 41414141, which means the 41, of course, the A that we are put on the list.pls. We can see the stack here is full of the here we can see that it's full of the 41414141, and we built the fuzzer and we entered it into a vulnerable application, and we can see that everything is good for now for us, of course. And I want to just make a very simple note, and I want to make sure that every one that watch this course, and especially this section, should have very let's say pre-knowledge. That's very, but that's not very good, but a pre-knowledge about buffer overflow, because I am not going to explain everything in depth. It's just how we can use a Python and how we can write our own Python scripts to simulate buffer overflow attacks, or not just simulate, but exploit a buffer overflow vulnerabilities. And it's not just specialized to talk about buffer overflow in depth and every detail in buffer overflow. So I want to make sure that is clear for you guys. And as we can see, we have a good progress. We make a good progress here, and we will talk about how we can move on and how we can just complete the exploitation with buffer overflow, of course, but we will test another fuzzers during the next lectures. Then we will pack to the to the point that we will need to complete the exploitation of the buffer overflow, and how we can control the EIP registry, then how we can test the buffer size, the exact buffer size, then how we can just put our shell code and execute the shell code on the remote machine or on the vulnerable machine, of course. I hope you guys enjoy this video, and see you in the next lecture.